Want to pop in everything in the chat again, Ellis? Just because there's been a number of people who've joined since.
Yep, there is the link for everybody. And we're going to get going in a few seconds here. So log into Slido. And we're going to start off with a quiz, mainly for us to kind of get a feel for where everyone's at. But yeah, so thank you all for joining us for day 2 of the clinical reporting in R workshop. Yesterday, we had a lot of fun going over how to teach you all, or how we're going to convert SDTM into Atom, going over a bunch of tools that exist in the Pharmaverse, and kind of ending with TPlyR. Today, we're going to be furthering that and explaining. You asked a bunch of really great questions at the end of the day, and I think we kind of had to end with good questions. We'll be going over that tomorrow. So our goal is to answer all those questions that you all asked yesterday today. But let's get going with some Slido questions. So let me bring that up real quickly. All right. Also, apparently, people have been asking where the Zoom link is, and it might have gone to your spam. You can email info@rnpharma.com, I guess, but everyone that would be here would already have the link. So if somebody could comment on that. But we're going to start with a quiz. So let's go with, sorry, we asked a bunch of quiz. So let's start with this one. Were you here yesterday? Yes, excellent. But you had to leave before the last session, okay? So it's looking like a good chunk of people were here and have already heard. We have some people that weren't here yesterday. That's fine. We're gonna do a little bit of recap, and then Christina will go into kind of level setting and making sure that everyone understands where we're going, where we're at, and where we're going from here. So yeah, bummer that y'all couldn't be here yesterday, but we've got the recording. All right, so now let's go on to our next question, which is, sorry that this stuff, my Slido quizzes keep on moving around. So, what tools exist in R for SDDM to Atom conversion? Talked a little bit about this yesterday. Some of you may already know. This is just a word cloud. I just want to see what tools you think exist. Meta tools, Admiral, okay. Metacore. So we like to see. Meta tools and Admiral. Exporter, yep. TPlyR. Haven, yes, exactly. Exactly. So we have a number of different tools that exist for R to SDTM, SDTM to Atom conversion. And you all are naming a lot of the tools that we talked about yesterday. So that's good to hear. But, you know, we got through to you all at least a little bit. And yeah, talking about also like Tidyverse, definitely a tool that you can use for SDTM to Atom conversion. That would be helpful. So now we're going to ask you a little bit more of a pointed question to see what information you got out of yesterday. If you weren't here yesterday, that's fine. Take a guess. So what is the prefix for the Admiral functions that create a new column in your data set? And Thomas, I want you to observe this and comment on this. I want to hear what you have to say.
Yeah. I think that 75% of people who joined yesterday have the right answer. So that's good.
And for the rest, we have to throw a couple curveballs in there.
Yeah. But yeah, it's looking like the crowd intelligence is working. So we have the right answer on top. That's good.
Exactly. Yes. So the correct prefix is derive var or derive vars, I believe. Cool. All right. So now how, if you're working on an open source project, like Admiral, like Metacore, like MetaTools, like tplyr, and you come across a bug, what do you do? Do you complain to your coworker and go, oh my God, I can't believe they did this? Do you just give up and go, well, anyway, that's not worth my time. I'm not going to spend any more time working on this project. Do you write it in your journal? Dear journal, I was using this open source tool today, and it gave me a bug, and I'm really frustrated, and I never want to use this ever. No? Okay, well, it looks like 100% of you, of the 50 that responded, or I guess the one of you gave up. But the correct answer is to report this to the GitHub issues pages, because that way the maintainer is aware.
Are you really sure? Isn't the first step always to complain to your coworker and then report the issue?
I mean, the eventual
You can choose
goal,
more than one.
yeah,
long
I
as
mean,
you
I guess
end up-
you could do more than one, except for that last one. Please do not email the maintainers angrily. They are doing their best to support you and try to make your life easier. Being mad at a maintainer just makes them feel sad and doesn't actually get your problem fixed. So report this issue to a GitHub issue, or on their GitHub in the issues page. Try to give them as much information as you possibly can when you've come across this issue. Try to narrow down, rather than going, I have an issue, and don't provide any context. Try to provide as much context as you possibly can to your maintainer. If you can come up with a reproducible example, come up with data and the exact code set that is giving you that error so that they can actually try to fix it and add your example into their suite of tests so that hopefully it will never crop up again. Yeah. Christina, Thomas, do you have any other advice for bug reporting?
My other advice is if you're confused about how to do something, so like that's a bug where you're like, this, I'm very confident to do this thing and it's not, and it's broken in this way. And sometimes you don't have those bugs. Sometimes you just have bugs where you're like, I think that it should be able to do this thing, but I can't figure out how. Those are also great bugs. They are maybe a bug that's like, just we need to add that issue, add that feature in, and that's great for us. It's nice to know people want to use our stuff and want to know what they. So it's good to know what people wanted to use it for. But also it's just, it might be that we need to improve our documentation. It's probably not on the user. I would say 90% of the time when you're trying to figure out how do I do this thing and you can't figure it out, it's not you, the user, who are doing it bad. It is us, the maintainers, who have, maybe lacked on documentation or weren't clear or haven't had that thing. So yeah.
Thomas, do you have anything else to add?
Well, I can only echo the last part. It's extremely difficult for a developer to write good documentation because you already know all this stuff. You cannot put your shoes into someone who has never seen this before. So whenever something doesn't make sense, feel free to raise an issue. The worst thing that can happen is, it's already provided there. Someone tells you this is where you have to look and the issue is closed, and that's fine. But don't feel like, you have to solve all problems on your own.
Exactly. Maintainers are usually doing this because they enjoy doing this. And so they're happy to help you most of the time. Don't want to speak for all developers, but all right. So now we're going to get a little bit back into what do you think is the most important you learned so far? So if you're here yesterday, we covered a lot of topics. We had a lot of different things that we talked about. Of course, those are all topics. So what is the thing that you learned it and you're like, oh, I need to take that back to my team. I am looking forward to telling them about this. We want to know so that we can make sure to talk about that more in the future. Okay, tplyr end-to-end workflow, add-on creation, creating data sets. Yep. Admiral tool. Yeah, Admiral's a pretty great package. Automation of tasks. MetaTools and Metacore, both great packages as well. So everything's moving around as I'm trying to read it too. Learning about packages, standard Atom implementation, Atom creation. I mean, yeah, that makes sense. Yesterday was focused around atoms, so that's exciting. That's kind of what you got out of it, because that was the point. I like, so perfect. This is fantastic to be seeing this. So that's what you learn. What is one thing that you wish that we'd covered more of? So that way we can keep that in mind today as we're going over the next steps of, now that we've created our atoms, now what? What is something that you wish we'd covered a little bit more in detail yesterday? I know that a number of you weren't here yesterday or had to drop off a little bit early. So, all right, you wish that we'd done SDTM creation. Okay, yeah, we started assuming that was already generated. Some more examples, we can definitely work on that. Of course, there are examples with the packages themselves. So you can go into Metacore and MetaTools and Admiral, and there's a plethora of examples that exist. And I think we're kind of trying to work on creating a more complete set of examples for folks, so they don't always have to go to workshops, I believe.
Yes, that is something that will be coming out in the near future. Some more examples. And kind of these end-to-end examples. These table formatting and mock shells, and we're definitely going to talk about that today. So that's definitely on the cards.
Footnotes and headers, great TLFs. Well, the thing you're here today, because we tried to split it up into 2 days to make it a little bit easier, because we obviously have a lot to cover. So that might be talked about a little bit today. Metadata structures, more in depth on functions, fair enough. It was great. I always love to hear that.
And more than one person said it too. That's exciting. Okay.
Love it. Love to hear it. All right. So kind of answered this a little bit, but what package do you use for reading in Atom metadata? So this is not the actual file itself. This is the metadata around atoms. Christina, this is yours.
Yes, it is. I'm giving people, I feel like it doesn't take very long because we don't hide the results. It's like immediately available. So you can see what the answer is. But yes, everyone, the wisdom of the crowds is correct here. To read in your metadata, you want to use Metacore. To make your metadata do anything fun and interesting, you want to use MetaTools. So Metacore is just going to be the engine for reading stuff in. But good job, everyone, for paying attention. So I think we can do the next one.
Yep. All right. I think this is the last quiz that we have. Oh, no, not quite.
Should be quick then.
Yeah, I think we have one more question. What function is used to calculate statistics like, but not only, mean and standard deviation in t-ply-r? We covered this a little bit yesterday at the very end. And I think we had a couple not examples, but
we did have examples, but we also worked through some of these layers with a bit of an exercise. And it does look
that was the
like
one I was looking for.
Again, the wisdom of second there, I was a little worried that but it looks like the wisdom of the crown group desk is correct. Group count is for doing categorical stuff, so it typically is just going to be your n's and percents rather than anything that needs continuous variables like means and standard deviations. So good job, everyone.
Perfect. And then the last question before I hand it over to Christina to talk more about kind of closing out a little bit of yesterday. what are we hoping to learn about today? You kind of touched on it a little bit with the what you wish you learned in day one, but I would love to hear a little bit about what you're hoping to pull out of today, knowing that yesterday we talked a lot about atom creation, and then we kind of went into using tplyr a little bit. What do you think is next? We also talked about it in our agenda.
Yeah. Well, it looks like TFLs are winning out, which is great because that's what I'm about to talk about. So, Ellis, I think I'm going to just steal this from you, or I'm not sure if I can actually steal. I can't steal. Oh, no, I can.
I've got to stop sharing, so our faces will get really big for a second, but then it'll go over to you, Christina.
Can
for
you
to
see
share
my
your
screen?
We can see day 2.
See day 2. We're here for day 2. Hello, everyone. So just, I know you probably know me, but I feel like I should say my name again because that's what you do when you start a presentation. Hi, I'm Christina Fillmore and I work at GSK. And I'm here to talk to you about day 2. So yesterday, we started off where we already had a set of plans already written out for us. We had our spec documents already written and all of that stuff, and we actually already had SDTMs. So yesterday, we started in the first half of the day, we made our atoms. We used Metacore and MetaTools to pull together some of your kind of like basic information and then use AdRoll to make that basic information interesting, right? We did all the calculations we needed and created a bunch of flags. So that was really great. We did that. And then after we did that, we did a little bit of analysis. We were just looking at doing the really basic summaries for things like your demographics tables, calculating your mean, your standard deviation for things like age, and also getting your count statistics. So calculating things like the n's and percents for different like races and ethnicities and stuff like that. So that was great. We did that, had a good time. Now it's time to move on to outputs. So one thing that we mentioned yesterday a bunch was about ARDs. So ARDs stand for Analysis Results Datasets. And we really think that analysis results datasets have the opportunity to solve a lot of problems. One problem that we have come across a number of times here at GSK is the fact that when you have things in a semi-formatted way, it's actually a little bit harder to deal with them than if they were just completely unformatted, or even if they're kind of fully formatted. Oftentimes we take our atoms and do some analysis and then get a submission ready table. And then from that submission ready table, we then need to put maybe a portion of that table into a CSR, or maybe all of that table into a CSR. But sometimes we want to change things about the table, whether it's removing percent signs or tweaking how things are aligned or something like that. Once you have a kind of everything already formatted, it becomes a lot harder to do those changes than to just apply them in the first place. And then even then, once we have a submission ready thing, the data analysis here, actually I can move this guy, needs to go into presentations. And again, we're going to modify the formatting ever so slightly, or even to publications. And for each one of kind of the spoke on the wheel, we end up modifying the formatting. Everything is going to look slightly different. And so what we found was actually it made a lot more sense to have completely more or less raw, unrounded analysis data. And that allowed us to apply the formatting kind of at point of use, as opposed to store it pre-formatted. And we think that that has a lot of value. So what I mean by kind of raw and unformatted is we mean that the analysis results data sets will look something like the bottom one as opposed to the top one here. So some key features are that they're going to be unformatted values. So in other words, unrounded. We're not putting percent signs in, we're not putting brackets in or parentheses, anything like that. It's completely unformatted. Here you can see that this is a character, and here we're keeping it as a double because we want them to be non-rounded values. Then another key feature is having one value per row. So rather than having the 3 and 3% or the 2 and 2% on the same row in the same location. We want them to be spread out. And we do this because it allows us a little bit more flexibility in terms of maybe you want particular formatting for percent signs that are different than ends or something like that. And it really, by spreading them out, it gives you the options to maybe you don't need to include percents, or you only need to include percents for the presentation you're trying to give. And it's a lot easier to do those kind of filtering changes when things are separated out. Another thing is that you want distinct columns for each grouping variable. So here we're looking at having, like you have treatment on both sides, but also you have in AE term, this is the one where it's probably the biggest difference. You don't have spacing in front and you don't leave the kind of blank system because this is going to be the overarching group, the blank filler row, I guess. Instead, you want everything to be completely filled out, much like you would have in, if you wanted to just do a basic group by, how you would want it to look. And the final thing is in ARDs, we believe you want to include everything you want to display, particularly labels or big N values. All of that should be in one single data set that then feeds into the table that you're trying to create. And when you have everything together, it makes it easier to build things later on. So I also just want to say that we at GSK are not the only people who believe in ARDs. And if you want to hear more and read more about why ARDs really have a lot of value, people at Novartis wrote this lovely paper about why we should respect analysis results as data. And so you can read the white paper. There's a link in the slides, but we can drop a link in the chat or in Slido later as well. But really, this white paper goes through and talks all the way more reasons about why it can be really helpful to have your analysis results, to give you that flexibility to potentially also reuse them in things like meta-analysis and stuff like that. Also, CDISC did put out a preliminary draft of a ARD specs this year. So CDISC is also thinking about creating a data standard for this. So there's definitely a lot of people who are involved in thinking about ARDs and think that ARDs are a good way forward. But they're not, as of today, they're not required by anyone. So don't get too spooked. We just think that it's a good thing. That's why we believe in them, not because we have to, because we want to. So now we before we go that, let me go back and let's look at what we did yesterday. So in the context of thinking about ARDs, let me go back to what we were making yesterday with tFlyer. So yesterday we made some basic tables, demography tables. And when we did these demography tables, we got something that looked like I didn't load in the data set. Once we combined everything together, we got something that looked like this. Table setup not found. Wow. Sorry, everybody. Let me make this bigger as well. Okay. So we got something that looked like this demog. And you can see why we would describe this as an ARD. It meets our requirements of what we're looking for when we're thinking about ARDs. And that's one of the reasons we really like tFlyer as a package, because it's able to create these kind of new data sets that we're looking for. So you have everything set, everything is out by itself. There's only one value per row. Everything's completely unrounded. And you have a kind of a column for columns. You have these row label 2, which is kind of your higher level row labels. And you also have your lowest level row labels. And all of that is in one place in one table. So that meets our kind of definitions perfectly. So that's kind of what ARDs are and why we believe in them, and why it makes sense for that. So now what do we do with an ARD? So an ARD, as you probably saw when you were looking at the tFlyer output, isn't the output that we put in our tables and things. It's not format. It is completely unformatted. That's why we like an ARD, but now we actually have to format them in order to get them ready. So that's why we built this TFlyer pack or this TFormat package. So the purpose of TFormat is to take these ARDs and gather some metadata to make it into the nice, beautiful tables that we want. So I'll talk more about the common TFormat functions in a second, but first let me walk you through the process a little bit. So how TFormat works generally is you're gonna spend some time defining table metadata. And then you're gonna take an ARD and that will TFormat will then format all your values according to this metadata, or it won't. Maybe you don't have an ARD, and so it's going to try and use this metadata to build out a mock table. And once it does either one of those things, then it will come out to a GT. So you go out to a GT because GT is a package, for those who are not familiar, for doing table formatting that is from RStudio, which is well, RStudio now Posit, I think, as of today. And it's well supported. And it also allows you to go out to a bunch of different format types, file types. So GT handles the rendering to go into RTF or to Word, which is really helpful for us because we don't have to worry about the rendering, which is hard. But also it makes it so that it's pretty kind of a universal standard, universal-ish, at least a very popular standard to go to for making a table. So let's talk more about this table metadata. When we think about tables, we probably think of them looking something like this. At least when I close my eyes and think to myself, well, what does a table look like? It looks pretty close to this. And it's full of component parts, whether you realize it or not. So one, probably the most popular part that you can probably think of is kind of this table body area, right? It's where all of this stuff is. So the main part of the table is the table body, and great. The next part is probably the columns. When we think about tables, most tables have columns. Columns tell us what's the table body, what's in the table body. That's really helpful. The next part is probably the labels and the groups. Again, this is used to inform us more information about the table body. We know that it comes, it's either kind of these treatments and here's what it is, or you might have weeks across the top and treatments down the side. There's a lot of flexibility of exactly how your tables will look, but they generally have labels and groups on the left and columns on the top. And the last feature of a table that we think about is these kind of these row groups. So a row group is going to be these sections where we have stylistic preference for everything within the group. So it might be that all of the things within this group should be styled the same, but also it might be that after your row group, you want to have, spacing after each one, or maybe spacing after some, but not all of them. And so those are probably what we consider our major component parts when we think of tables. So to break that down into how does that relate to anything we're talking about, we've built this package called TFormat, and how TFormat works is it allows you to specify each kind of component part individually as a plan. And so when you have, how am I going to round all of these values and which ones get combined together, you can get a body plan, and it will then in the body plan, you're allowed to specify all of this information. And so it makes it easy to explain what goes where. Then similarly, for the columns, you might want to set, these are the order of the columns I want them to go in. I want these ones to be capitalized. I want to change the name of this or something like that. You can do that using the column plan. And then finally, you wanted to control the kind of styling between the groups. To do that, you can use the row group plan. So this might all feel a little bit abstract, and I saw that there was a hand was raised. And so if you do have a question, can you put it into Slido, and hopefully Ellis will be able to answer it, or maybe Becca. But also I am going to get into code in just a second, so that probably might make things make a little bit more sense if that will help as well. So just talk through the plans a little bit and kind of how it works. So let's see the in action. So TFormat works by allowing you to specify how these columns over here become these columns over here. So first, you're going to be able to, first you want to supply that information. So it's going to take things like group equals capital G group. So this is saying in your ARD looks like this. Your ARD has 5 columns, group, label, column, param, and value, all of them capitalized. And group, in your TFormat, in the code, you're going to say group equals capital G group, and that's how you indicate that this group column ends up in this location on your table here. Then you're going to want to do that again, except for this time we're going to put in the label and says label equals label, and this indicates that this column here is meant to fit into this column here, which is kind of the closest thing in. So it's that last column just before what your data is. Then you're going to have column equals column. Again, capital C column, because this is a capital, everything over here is capitalized. And you can see that the placebo, treatment, and total end up as the placebo, treatment, total columns over here. And it does that kind of pivoting for you, and all of that is managed. And then the other thing that you're going to want to do is say where the values come from. So this is where are the values in your body of your table, where do they come from? And they come from the value column over here. So this looks really great. This seems to have most of the things covered, except for the things around the mean and the SD. These are 2 different things that are combined together. Or if you think about these values, these are ends and percents. And you can see clearly that the formatting, for instance, for mean and SD are not the same. This is only rounded to 1 decimal place, where this is rounded to 2. And so you're probably going to want to be able to specify that. And to do that, you're going to use this param column. So the param column here allows you to put in the information to say that this value here represents this information. So this value here, the 73.56, represents the mean for the placebo column in the age. And so when you do that, you can see that how that information kind of transfers over. And to put that into your TFormat object, you're going to use param equals capital P param. So that's how that goes. To specify, so you're going to take, just to recap for a second, you're going to have your TFormat object. Your TFormat object is going to allow you to collect all of this metadata about the table you're trying to make, to allow you to combine that metadata with your ARD to produce a table. And so we're specifying bits of metadata, in this case, what columns go to what parts of the table, to then allow TFormat to render that for you once you choose to print it out. So we've done that. That's how we've specified a bunch of general things, but now let's go to specifying some actual things in the body plan. Let's like really specify how we go through and do all of the rounding and all of the combining of those sorts of things that we want to do. So first, let's take this value, the 15. How does that 15 end up over there? And what's going to happen is, first, we're going to specify how we want to round it. You see the 15 on the left is 15.00, and it has to become the 15 on the right, which is 15, no decimal point, totally rounded. So to do that, we're going to specify the formatting. We're going to say that the format should look like this. Format XX. We kind of use a say what you see sort of mentality to specify information in your TFormat. So if you want it to look like this, in other words, 2 digits with no decimal place or anything, that's what you want to write, because that's how you can get it to produce that. Okay, wonderful. So now that we've done that one, how do we know that this should be rounded like this, but not everything else? And you do that by using the format structures. So we use these things called format structures that let you specify the location of the thing you're going to be applying the formatting to. So the format structure is made up of kind of 3 parts. the group val, the label val, and the format itself. So the group val specifies the value of the thing in the group column that you would like it to be, and the label val lets you specify the value in the label value that you want it to be. So what this is saying is that for all of the times, .default means that for any group that has a label of n, the formatting should look like this. So that means for all of these ones and all of these ones, the formatting should look like that. So you can see that this format structure applies to these things over here. And once you've specified one format structure, that's probably not going to do your whole table. Typically, tables are made up of things that have a lot of different formats. So to add another one, we just put another one in. So this time we will add another one, and we're going to look at using the mean and doing the mean and standard deviation. So again, we're going to specify the group val, and this time we're going to be specific. We're going to be specific because only age in years has the mean and standard deviation. Sex doesn't. So we're going to say for the group val of age years, we want the label value. And when the label value is mean and standard deviation, we want it to look like this format. So we want it to look something like this over here, right? But that's a bit tricky because unlike the one before, it's not a single value. There's means up here and standard deviations. So we need to supply formatting for both of these things. To do that, we're going to use what's called FormatCombine. So FormatCombine allows you to combine as many things as you would like, so as many parameters as you have, and you're going to specify what the parameter should look like, or what the parameter is, and then how it should be formatted. That. So you're going to use kind of the same as if you're familiar with string art, it's kind of that same sort of pasting concept. So anything in curly brackets means that it's going to be looking for a parameter. So curly bracket mean says, in order to combine the means and the standard deviations, what you're going to do is you're going to put in the mean and then a parenthesis, and then the standard deviation, and then another parenthesis. And then below that, we're going to just define how we want those to be formatted. So the mean should be formatted like this, which is XX full stop X. In other words, something that looks like 73.6. And the SD should be formatted like this, with 2 decimal places rather than just 1. So something kind of like 9.35. And you can see that this label, or because we specified the group and the label value here, it's only going to apply to this one row, because that's the only conditions that match that group and label combination. So now we have this last 2 left here. And so we're going to specify those as well. And we're going to specify them by using by just putting in default values for both group and label. And the reason we're just putting in default values is because how Bodyplan works is Bodyplan will take whatever the last thing it sees. So because these match to this and these match to this, it kind of goes from the bottom up, and these 2 rows won't match to these 2, so they're going to match to this one, which will, because it's default, will cover everything that it can. So here we're going to combine ends and percents. So you can see the ends here. I actually didn't put in the full ARD because it was just too big to see. So you have to trust that there's an ARD longer than this. And when you do that, it's able to go and map them over here. So again, rounding to 1% point, 1 decimal place, because you can see there, and putting in the X's. So now that I've kind of talked through this at a high level, I think there's probably still some questions and people would probably like to see it in action. So I am going to just run through high level, what are the functions, and then we're going to get started and do some examples, and we'll work through it together to see if it makes more sense. So first, we're just to cover what TFormat does again. Remember, it takes those ARDs, which are basically just any sort of unformatted analysis results data sets that have one row per value, and then it converts them into tables. And so it converts them by collecting all of the metadata using this TFormat object, this TFormat function. And you put all of the information you want in various plans, whether it's the body plan, the column plan, the row group plan. And you're use things like the format structures and FormatCombine, FormatWin, and Format to define the exact formatting of how you want things to look. And once you've done all of that, you then print the table out into a GT object. So you can print to a GT just straight, and that's if you have an ARD, or you can print to a mock GT if you don't have any data and you just want to make a mock shell. So that's a lot of information I've thrown at you. Let me get into showing you exactly what I mean.
We do have 2 hands up and we have a number of questions. Do we want to answer these questions or have you go through the code first?
Well, I don't know what the questions are. I struggle to answer that fully.
Why don't you go through the code first and then we can answer questions. Just wanted to make sure, because some hands have been up for a little bit, they're aware that we see them and we are not forgetting.
I've seen hands. I realize we've kind of gone full in. So let's all just come to 07 basic table really quickly. We'll run through this relatively short piece of code. And then we can have a bit of a chat, because I do realize that this might be a lot of information being thrown at you. So here, the start of this code, just the top of the code, clear off everything I've done just to clean up everything. The top of the code just makes the table that we were looking at in the slides. So you can see that this is the same as the data set we were looking at before, except for this time I've completely filled it up, right? Like it's all there. The ends, the percents, the means, the SDs, everything that you would want to see is right there for you to see. So let's start by doing our first little TFormat thing. So I'm going to call this the first TFormat. And what we're going to do is we're going to start by setting up a TFormat object. This is what we're going to use to put in our metadata in order to specify how we want our table to look. So just like what we did in the first slide, is we're going to specify what columns should go to what. So if we look at our little data here, I'm going to just look at it in the environment on the left-hand side here. We want the group column to be equal to capital G group, because that's what it is in the data set. The label column is going to be capital L label. The column is going to be equal to capital C column. The param column is going to be param equals capital P param. And finally, the value column is going to be the capital V value. So that's my first little TFormat. And I'm going to take that TFormat and I'm going to print it in, I'm going to print this out. So I'm going to print this out by taking my first TFormat, and then I'm going to call print to GT. And I'm going to supply the data I have. So that data in this case is called data. And when I do that, I have to run this code. And then when I do that, what can I spell? Oh, one first learns how to spell the word first, and then they'll be able to look at the table they've just made. So this is what our table looks like. It looks pretty similar to what we had before, right? We have, the 15, 13, 28. That's kind of what we had in the slides. But then when we look down at the means and standard deviations, we see that this doesn't have the parentheses around it that we wanted. And the ends and percents look even worse because they just have so many numbers that it's actually kind of hard to read. I mean, it's not horrible, but it's not that pretty. So let's spend some time prettying it up a little bit. So the first thing we're going to do to pretty up is we're going to add a body plan. So we're going to take our TFormat. I'm going to just copy it from up above because I'm a touch lazy. So I'm going to copy this. Boop, 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 boop. Went too far. And now I'm going to add a body plan. So the body plan is how we remember the body plan is how we plan to format the body of the table, which is probably the most glaringly obnoxious thing to look at right now. So the body plan equals the body plan. And the body plan is made up of a list of format structures. So we're going to make a format structure. And in this format structure, we are going to just deal with the n% things because that's the one that has kind of the worst look. So we're going to say group val equals dot default and label val equals dot default. And then we're going to put in our format. So we're going to use a FormatCombine because the last two rows, the male and female rows, both are n% rows, right? They're ends with percents in them. So we are going to say we want to combine them by making it so that it goes n and then space, parenthesis, percent. And I know from having written this before that it is PCT in our data set, but we can just take a double check here and see that this is in our param column, it says PCT. So we're matching what it says in the param column. That's perfect. So now let's select what actual formats we want. So we want the ends to look like something like this. Oops. And we want the percents to look kind of like that, except for this time we're going to add in a decimal place. Oops. And when we run that, we'll just call this rounded TFormat, which might not be exactly the same name as you have, but I can't remember. So we're going to put this in and we're going to say, just like we did before, the rounded TFormat goes pipes into print to PT, and we're going to provide our data. And this time when we do this, we get something that looks pretty nice. Like it's not bad. I mean, the orders of things have gotten a bit switched, but that's fine. We can fix that next. And now this looks rounded. There's a percent sign here. It's much easier to read. And we've also gotten this fun little note here that tells us that not every row has formats applied to them. And in fact, you might want to add a format structure that looks like this in order to resolve some of these issues, which is perfect. I would love to add that. So I'm going to just copy because again, typing is hard. So this time, I'm going to just pop this format structure and put in some spaces. So just like up above, we have a FormatCombine, and this is for the mean and standard deviation that's here. So this is under age, Y, mean, standard deviation. It should look something like that. Perfect. So if I do that again, and now I've taken that one along, I get something that looks like this. Well, I didn't actually want them to have just a comma between them. So let me change that. I'm going to change that by putting this in here. And I'm going to put that in parentheses. And also when I look at my standard deviations, I want to have 2 decimal places, and I'm going to make my mean only have 1 decimal place. And also when I look at these standard deviations, I see most of them only have 1 digit. So actually all of them only have 1 digit. So I don't need to say there's 2 digits here. It's fine if you do, it just adds a space, but I don't want that space. So I'm going to make that go away. So when I do that, now I get something that looks like this. This looks pretty good. It's pretty similar to what we had in our PowerPoint, that table we were looking at. So, oops. So that's really great. So now we've kind of done all of the rounding pieces, except for I'm still getting a little notice about some of them not being totally rounded. So just to make that notice go away, because it's saying they've not applied any formatting to these rows here, the rows that are just ends. So let's fix that. So to fix that, again, I'm going to just add another format structure. And this time I'm going to say group val equals dot default, because both for sex and age have an N group. So I want to cover both of them. And label val equals N, because I want the things that are labeled N. And this time, because I don't need any sort of fancy formatting, I'm going to just put it like that. And so now, finally, our rounded thing, we don't get any other messages other than these things which come from GT that are being fixed. And so we can kind of just ignore them for now. And everything looks really good. So, but I would like things to be in order. They weren't in order before, so let's put them in order. To put things in order, all you have to do is set the sorting columns. So I don't really want to type everything I just typed. It's a lot of typing and I'm live coding and that's not fun. So I'm going to do something where I can just layer them, because it turns out TFormats can be layered, kind of like transparencies for those of you who are old enough to ever have used transparencies in class. And if not, it will take whatever's on top. When you have two things that are different, it will take the one on top. But if they're the same, or if there's one there on one of them and not on the other one, it will just take both. Not sure if that made any sense, but we're going with it. So we're going to take our rounded T format that we were using before and pipe it into another T format. And this time, we're going to say that the sorting columns, sorting spelled correctly, they're going to equal ORD1 and ORD2. Because we can see ORD1 and ORD2, and it would put this in the correct place, and it would sort all of that out. And so that seems like a really great choice. So then if I print to GT for that and put in my data, I can see that looks pretty good. That's pretty close to what I wanted. Let's just get rid of the variables that I don't want to see, and then we should be good to go. So to get rid of the variables I don't want to see, this time I'm going to add in a call plan. So the call plan allows you to plan what your columns look like. So I'm going to put in a call plan, and I'm going to say call plan equals, and let's see, what do we want? First thing we want is we want the placebo spelled correctly. So we want the placebo, and then we want the treatment, and then we want the total, and I'm going to drop the ORD. So we're going to say minus starts with ORD. When I do that, I get this. This looks almost perfect, right? It's basically exactly what we had within our PowerPoint. So that wasn't that hard to do. And it made it look exactly what we wanted. So I'm going to just call this the ordered T format, just because there's one more thing I want to do. For those who are truly eagle-eyed out there, will notice that the one difference we have between this little image right here and the image in the PowerPoint was that there was a bit of a space. So we had a space after the age row. And to do that, we can do that again. We're going to add a row group plan. So to add a row group plan, we're going to take the T format that we have. So our T format, our ordered T format. which does not look right. Or TFormat that I just wanted to make sure was the right thing. And then I'm going to pipe that into a TFormat again. And this time I'm going to say the row group plan equals a row group structure. Oops, I don't need to. Row group plan equals row group plan, sorry. And my row group plan is made up of a series of row group structures, very much like the body plan. But this time we're going to just set what we want for the age. I've decided I only want a space after age rather than everything. I think in the default, in the code that you guys have, you potentially have it after both of them. It doesn't really matter. It's whatever you would like to see. So here I'm going to set it as .default, or I'm going to say it's going to be age in years. That's the group that I have, and I want there to be a space afterwards. So for that block, we want there to be, oops, that block, we want there to be a post space that looks like this. Oops. So that was probably a lot, but let's just see how that looks. When I do that, and I print that to GT with my data, I'm able to get that little space. So you can see I now have that little space that I wanted. That matches what I have. And I could even add in a little title here that just says the title is going to be something like my mini demography. So something that looks like that. Now you can see that this is my mini demography table here, and it is exactly what we had in the slides. So you can see down here, this is the full one. You could put it all together all at once, or you can do it in parts. It doesn't really matter. But it is kind of a lot to be always typing. And so one of the other things that we have available for TFormat is we have these things called templates. And how templates work is templates allow you to put standard formatting into functions so that you don't have to do them every time. So in this case, we have n%. N% are a pretty common formatting style that you run across. You'll see them all the time in AE, everything from AE tables to demographic tables. And so here we have this for TFormat n%, and we're going to pipe it into the TFormat. Just like with the TFormat up above, we're specifying the group, the label, the column, the value, the param, all of that sort of thing, the sorting columns. But now when we look at this body plan, we only are specifying the n and the mean and standard deviation. We're not specifying anything else. And so if we run that together, we can see that we get the same thing basically. The only difference is that one little bit of a space, but that's just because this is by default rather than age years. So that's the very basics, somewhat fast, of TFormat. Ellis, I'm gonna stop sharing. I don't know. Should I stop sharing? Should I stop sharing my screen, or do you want to just handle questions? Do you want to lob some questions at me?
Let's lob some questions at you. So, Monica, I am going to allow you to talk since you've had your hand up for a minute. Then we'll go to Marco, and then we'll go to some Slido questions. Remember, if you have questions, Slido. Oh, looks like you dropped your hand. If you have questions, ask them in Slido, or you can raise your hand now. So Marco, you're now up. Monica said it was a mistake. Marco, if you'd like to talk, now's your time. Time to shine.
Do you want to give me a question? Oh, go. Oh no, Marco's hand went down.
Marco, your hand went down. Okay. So how about this? Sorry, trying to read these. There's a number of them. Can we create conditional formatting using if else?
You don't have to use if else though. So conditional formatting, I'm going to put in a conditional format that won't make any sort of sense, but it'll be easier. So let's just say that for whatever reason, you wanted this format. So whenever the standard deviation was greater than 9, you wanted to make it say something else. You wanted to say undefined or something. So we're going to use a format win to allow you to do that conditional formatting. Format win has a style that's very, very similar to kind of case win. So we're going to put in here when we say that it's greater than 9, because that's the thing we want it to look like. We would like it to say, I don't know, undefined. But if it's less than 9, so when it's just true, so for all other values, we would like it to have that same formatting that we had above. So we want it to be, you know, something like something like that. So when I do that, now you can see the one that was greater than 9 is labeled as undefined, but everything else is not. Here I can remove those X's. So, but you can see because we put the parenthesis up here, that all of these are still in parentheses. But for instance, if we didn't want that, if we wanted it to just say undefined, but not in parentheses when it was undefined, but in parentheses otherwise, you can also just move the parentheses down to where that is, and that will change that. So you can have it look like that as well. So you can have a lot of flexibility with your formatting. You might use, if you need to use like format wins or format combines, you can use everything kind of in combination with itself. So.
Perfect. So we got asked this a couple of times. Does it matter if you use format capital XX.X versus format lowercase xx.x?
No, I use them interchangeably because they don't matter. And I can never remember if I'm not consistent with myself. So don't worry, we've not made anyone else be consistent with anything. So it doesn't matter.
Yeah, it takes the value. All that we really care about with the format is the number of X's and like the way that it's structured, not the capitalization. The values that are not those X's, capitalization does matter and it will respect that, to be clear. Where did it go? Is there a decimal alignment option?
Yes, there is, but to not steal Ellis's thunder, we're going to look at more advanced features in a moment. But first, we are going to, play around a little bit more, get a little bit more used to it, have an exercise where you guys get to play with it, and then we can look at some other features like decimal alignment.
Yes. Okay, we've got a few more questions. I think these are good ones to ask everybody. How to include horizontal lines between rows?
If you want a horizontal line, you just change what your postspace. That's why we have the option here. So if you make it like that, now it's all horizontal lines.
There you go.
And all I did there, just so everyone can see, is I changed this post space. So this post space option lets you specify what kind of post spacing do you want. And so in this case, because I said post space should be lines, it made it lines.
Very nice and easy. How is rendering a formatted output into output files handled? Which formats are supported? And for HTML output specifically, how is integration with example CSS?
Yeah, so this is why we use GT. So the thing that comes out is a GT object. So GT allows you to use CSS with it. So you just use that. All of those features are kind of within the GT package rather than within our package. So GT at the moment handles rendering out to Word, RTFs, PDFs, Am I missing one, Alice? I feel like I'm missing one. I'm definitely missing HTML. HTML. And so it works with all of those. And I mean, you can see with the tabling package but the tabling, there's always a tabling contest that our studio runs. And I think
it's going on right now.
It's going on now. Your examples are due in on the 5th of November, if I want to say. And
Like that.
something like that. And you can, a lot of those tables are made with GT, and you can see all of the beautiful options that you have. So because we go out to a GT, all of those options are still available for you.
Okay, so I got a couple questions about GT. Is GT available in our studio?
Yes.
You mentioned it may not be available after tomorrow. So GT is a package from our studio who is changing their name to Posit. Our studio / Posit is not going away, and GT has a lot of support from, let's just call it Posit.
Yes.
The main developer, Rich, is a fantastic guy that is like all in on GT and is spending a bunch of time on this. He actually gave a workshop, not on GT at RM Pharma. He gave it on another package called Point Blank, but he is extremely on the ball for handling GT issues and is constantly responding to people and helping them out with stuff. So,
and Rich also does want to make GT work for the pharma context. So I know right now, for instance, there's some slight nuance in terms of how people would like their footnotes to look in an RTF file. And Rich is kind of at the moment gathering feedback about how people want that to look. So if you have strong feelings, we can drop a link in terms of where you should post about it. But Rich does want to make this work for us, and we have been working with Rich in building this. And so if there's something that you feel like you like GT, but it doesn't do X, Y, or Z, please either tell us or Rich, and we can work to try and see if it will allow for that or why it's not allowing for that, and work with you on those sorts of things. So definitely, Posit wants to make GT available for pharma, if that makes any sense. So
make it more friendly for us to use.
Exactly.
And then I think the last question that I'm seeing, unless Becca, you want to message me, or Thomas, you see a question that you really want to answer, is can you add headers? So like titles and subtitles.
Yeah, you can add titles. So we added a little title before, but we will add it again. So titles are just called title equals, and then whatever you want it to say. So I think before I called it the mini demo table. And then we also have subtitles, and subtitles equals, you do subtitle equals the thing you want. So the thing that's slightly unusual about TFormat is because we have so many parameter options, we do require you to name every parameter that you put in. So in this case, subtitle equals maybe hello world, because I'm not that creative. So if you put that in, you can see we have title and subtitle. You can left align them and all sorts of things, but to do those sorts of changes that you use GT for. But we can show you how to, if you want to see how to do all of that, we can show you that later on this afternoon. But yeah.
Cool. And then, yeah, there's a question about footers, but we're going to be getting to that later. So I think with that, I think that's all the questions we have time for at the moment.
Okay. So it is 3:12. We can do a show of hands. Does everyone want like a 5-10 minute break, and then we can come back and make our demography table? So when we come back, we'll do file 8, and we're going to make our actual demography table using our ARDs from our little study that we've been working on. Does that sound good? 5-10 minute break?
Sounds good. So we'll be back in 5 minutes. So that will be 18 minutes after the hour. for more information. And to clarify your Slido, because there's a lot of you and only a few of us.
Okay. So with that, I'm going to restart here.
Stop sharing. So y'all are asking great questions. Continue to ask.
We love questions. Questions are the best. Okay. So continue. Can you see my screen, Ellis?
Yes.
I hope this makes sense to everyone in terms of what I'm doing. So I've now moved to 08. And so I am going to just go in there. So this time, what we're going to do is we're going to build the demography table that we want for our actual like little study. So rather than just the little dummy example I was using before that only had kind of the age and part of the age and part of the sex, I'm going to actually do the whole kit and caboodle of a demography table. So the first thing I'm going to do is I'm going to load in my demography. I'm actually going to clear my screen just as well because I like to have a clean and tidy place to work. So I'm going to load in my demography table, and let's look at this. So our demography table looks a lot like the thing we made with tPlayer earlier today / yesterday. So it's basically the same thing. All's good. Wonderful. Perfect. So I can take that, and now I can use that to start making my demography table. So the first thing I'm going to do is I'm going to actually start with a template, which is kind of what I highlighted in the other one, but just because I'm a bit lazy, I don't want to have to write out everything. And I know that demography tables have a number of categories where it's just an N and a %. So that's where I'm going to start. So I'm going to use TFormat, N%. And then I'm going to put in a TFormat. I'm going to type that into an actual TFormat. And in this TFormat, I'm going to specify all of the stuff I need. So I'm going to make this a touch bigger just so I can see this here. And I want to look at this because I want to get the names of all of the columns that I'm looking for. So my group column here is going to be called row label 2. That's the highest level grouping column. Next, I want the label column. You don't have to do it in this order. I just like to do it in this order. And that's going to be row label 1. And you can see it's row label 1, because that has like F and M. That's what I want to be more in. This is what I want to be at the highest level. So then the next thing I'm going to put in is the columns. So the columns equals col 1, and the param equals param. And then the value, which is where my numbers are, you can see the value is in the value column. Oh, can't put an enter sign in. And finally, we're going to put in the sorting columns. I'm going to put the sorting columns in first this time, just because I know I'm going to need them, and they're right here. So I'm going to call this ord 1 and ord 2. Perfect. So this is going to just be like my demog. Run that. And I'm going to take that demog TFormat and I'm going to print my demog TFormat and type that into print to GT. And this time, instead of putting data in, which is what we did last time, we're going to put demog because demog is our data set this time. So we do that and we get something that looks like this. So look at this. You know, that looks good. That looks not so good, but like a lot of them seem more or less what I want to see. And then it's very not what I want to see. So let's fix that. So the first thing I'm going to do here is I'm actually going to do kind of what I did last time, where I just stole from this bit down below. That's because I'm lazy and I like to not have to type things. So I'm going to take my demog, TFormat, and I'm going to pipe it into another TFormat. And in this TFormat, I'm going to have my body plan to plan out how I want to do the rounding for some of these things. I'm going to put my, not my bossy plan, my body plan. And I have some format structures here. So here's a format. I'm going to just take this first one, oops, and copy it from the console into this and put in some entries so I can actually read it. So here, this is for when we have an age, year, mean, standard deviation. So if I look down here, I see that there's actually a bunch of things that have mean and standard deviation, not just age, year. So I'm going to take this and change it to dot default, because this applies for a bunch of things, and put mean and standard deviation. That's the label. And here, I don't want it to look like this. I want this to have, I want my mean to have a single decimal place and my standard deviation to have 2. So we're going to change that as well. And I think finally, I'm going to put, not have a comma there. I'm going to just tweak this to be what I want it to look like. Okay, so that looks good. That one will do our means and standard deviations. We now have to do the medians, the quantiles, the mins, max, and then the missing in the end. Okay, so copy like the speed of light. I'm going to put a copy in my mins and maxes. And this one I'm actually happy to leave as a comma between the mins and the maxes. That makes sense to me. Might even put some square brackets around them, just because I like square brackets. I'm not going to put, no, I'm going to do 1 decimal place for min and max. And then I'm going to, again, change this to dot default because I want that to apply to everything, not just age, years. And then I'm going to do the quantiles really quickly. Very quick versions of these things. So again, changing that group to dot default because we want it to apply to height, we want it to apply to weight, we want to apply it to age. Everywhere should apply the same. This one, I'm not going to do any changes on. I think I'm happy with only having 1 decimal place. If you feel like it should have more decimal places, feel free to edit your code and add as many decimal places as you would like. So now just to do the last ones and this format structure, I'm going to do root val equals dot default, like before. Oops. But this time, I'm going to say label val equals, and I'm going to make it a vector because I actually want the label to be, the label is n or the label is missing, because they're both going to be flat ends. I want them to be treated the same. I'm going to say that the format will be something that looks like this. I'm only going to put 1x because sometimes there's no missing and I don't want to add extra spaces if there's not any. If you only have 1x like that, it's fine. It won't ever cut off anything. So like these hundreds will stay as 100, but these zeros also won't have any leading spaces in front of them. So lovely. So that's good. So now let's look back at our full body plan really quickly. So we have a body plan that has mean, standard deviation, min, max, Q for the quantiles, and then N and missing. I think that covers me. So I'm going to just say, call this one, trying to keep what I said before. So I'm going to call this the rounded demog. Yep. And if that's my rounded demog, let's have a quick look here. Does that look right? So in my rounded demog, I'm going to take it, and again, we're going to print it using print to GT, and we're going to put in our demog data. When I do that, still a little bit mad at me about something, but let's have a look here. Oh, it looks like the medians. That was what is left unrounded. I didn't do median, but everything else is looking pretty nice. So I'm going to just quickly pop in the median because I forgot to do it. And I think that the medians should have, I'm going to copy this because I'm incredibly lazy, even though I need to change a bunch of things. I'm going to say that that's my median spelled something like the word median. And this time my median is going to have a decimal place, like the mean. And to the question about does it matter if I have different x's, you can have even different x's in the same one and it will be fine. But look at that. My message about not applying to everything went away, so that seems good. And it looks like a bunch of things got rounded correctly. So that's nice. This looks kind of like a demography table. Perfect. Okay, so let's go back to it. So I now have something that looks more or less correct. Now that we've done all of the rounding that we need to do, let's do some changing around with indentation. So here I have it so that I have my rounded demography table. So this, remember, has all of the columns from our ARDs specified and all of our rounding done. Now we're going to put in how we want these things to look. So at the moment it's put in as indented, and that's what the default behavior is. So it will by default look like this, but maybe you want it as a separate column rather than kind of this indentation. So you can say column. I run that. Oh, did you change this thing? No. Then you print it. Sorry. You get something that looks like this. So you can see now that it's come across as a separate column. And that looks pretty good, except for the fact that I think I like it indented better. I'm going to change it back to indented just because that's what I like. I like that better, personally. So that's what I'm going to do. Okay, now go back to making our thing. Oh, that was it. That was all for this one. Well, that was faster than I expected. I'm actually also going to do a couple of other things. Oh, I did remove some orders. So I'm going to remove the order columns because I didn't want them there. And then I'm going to put in a title. When I do that, now this is perfect. This is exactly what I want. So this probably looks somewhat familiar to you. I'm sure you've seen a demography table before. And so that's really great. Now, I did have to do kind of a bit of typing in order to get all of the formats. It wasn't horrible, but it maybe could be a little bit better. So one option you can use, this case probably doesn't make as much sense, and anyone can develop their own templates. So if your company has a standard way of doing demographic tables, you can definitely make your own template to have the demographic tables so that they always look perfect for what you guys do. But in lieu of that, we've only made a kind of 2 ones that are default. And so the 2 ones that we have that are built in there are the N%, which we talked about, but also this one called TFormat SIGDIG. So how TFormat SIGDIG works is you supply it with a data set with your row names and your column names so that this has the values for each of your group and your label. So remember, our top level group is actually group 2 and our label group is group 1, or row label 1 and row label 2. And then you set a base significance. So in this case, we're going to say our base significance is 0. Potentially doesn't make a huge amount of sense right now, but let me show you. So then we're going to supply that data set to our TFormat SIGDIG function, as well as with our group and label columns. So again, just saying that row label 2 is our group column and row label 1 is our label column. And then we're going to provide what we call the param defaults. So we have this little function called param set that helps you specify them, but you don't have to use this. You can put in any named list, or it's a named vector, and you just named list actually, and you put in what you want. So you want median to have 1 decimal place, you want mean to have 1 decimal, standard deviation to have 2. It should look fairly similar to kind of what you've done before. And if you use that in combination with your little n%, all you have to do then is put in, to get the same outcome, all you have to do is put in your columns, your params, your values, the sorting columns, which is what we did up above, as well as the row group plan and your call plan. But other than that, you don't have to specify any particular format structures for this particular table. So that is an option if you want to do that kind of param-based, or not param-based, but like label-based or group-based formatting. So this makes more sense for a lab data set probably than a demography one, where in your lab tables, oftentimes you want your rounding to be a significance based off of the param value that you're looking at. So like whether it's hemoglobin or creatinine or whatever, you can do rounding that way. This is just a fun little thing, but you don't need to worry too much about it. So with that being said, now I've felt like I've talked for ages, it's your turn to have a go. So what I want everyone to do is open 09 AE table, and there are some questions for you. We'll give you like 30-ish minutes, 30 minutes, I think.
Minutes.
30 minutes. So come back at 5 past whatever hour is the next hour in your time zone. So for me, 4 past 5, 5 past 4, sorry. And then we will go through the answers.
Yep. If you guys have any questions while you're working on it, post into the Slido, and we will do our best to answer those. Y'all have been asking some good questions here. One quick thing that somebody did ask is, what does the tilde mean in row label 1 in the tribble function? And so that's based tribble.
Oh.
The tribble function allows you to define. Oh,
sorry, that was me. I clicked buttons I should not have clicked. I'm very sorry.
Okay. The tilde tells the tribble function this is a column name. And so you need to list all your column names at the very beginning of your tribble. And then you list the content below. So
basically, if you haven't seen something like this, the Tibble package allows you to make Tibbles in 2 ways. The Tibble way you probably know, which is something that looks like this, where you list everything out, or you can make a Tibble that looks like the thing you're making. So in this case, the significance data set looks like this, and it looks like this because we've said, as Ellis was saying, the tilde, this is the column name, tilde, column name again, tilde, column name again, and then you just kind of put in as much as you would like. So you can put in, I can put in hello. Again, I'm still not creative. So this can be hello world and, 2, for instance. And when I do that, now my data set looks like default, and then hello world 2. So it's just a way of making Tibbles that are slightly more visual.
yeah, it reads a little bit nicer. But yeah, so we'll give y'all 30-ish minutes. Ask any questions you have in Slido, and we will answer them. And we might bring it up to the larger group when we come back.
Okay, everyone, we're coming to very close to time. Before I start going through the answers, which I will wait until exactly 5 past, like we said we were going to do, I do just want to show the fun thing I kind of mentioned, but didn't actually show. So can people see my screen? I'm assuming that's a yes.
Yes.
Perfect. So somebody asked about special characters and adding like the plus minus symbol in, which they gave an example of the plus minus symbol, which has this Unicode. So if you wanted to ever add Unicode, all you need to do is add it in. So when I do something like this, just put the Unicode in between the two things. And I print it out. You can now see that the mean and the standard deviation has this little plus minus symbol in between, because that's the Unicode for that plus minus symbol. So it works fairly well with like special characters. If you ever want to add in special characters, that's how you do it. Which I just never thought to test, and someone brought up. So thank you for whoever you are. But don't you worry, that thing works. So that's what I was talking about. Yeah, now give you need to get both those days in. Okay, so it is now 5 past, and so we can start on the thing on the answers. So the first question had to do with, so first it suggested that we looked at our, I'm gonna just clear my environment again because it's nice to clear my environment and make it small, not big. So first thing we're gonna do is read in the data set and look at it. So this looks like the AE data set that we made yesterday using the T-plier stuff. So you can see it has that any body systems and the cardiac disorders, distinct ends and distinct end percents, and all of that looks gold. Okay, so let's get started. So the first thing it says using the TFormat end percent template, create a foundation of a foundational T-format for an AE table and print it. The goal is to have treatment across the top with the AEs going vertically. Perfect. So the first thing that we're going to see here, it gives us a hint of we might need to look at these n percents, is when you look at the T-format n percent, it assumes that your parameter values for n and your parameter values are for percent are n and percent. But if we look at our data, we don't have that. We have distinct underscore n and distinct underscore percent. So we will need to adjust those expectations. So what we're going to do is we're going to just call it n percent. We're going to say n equals n distinct n, sorry. Distinct n. And then also we're going to say that percent equals distinct percent. Okay, perfect. Turns out I don't know how to spell. Nothing new, still can't spell. Perfect. We get something that looks like this, and this is just the inside of our T-format. It's kind of the guts, which is not that exciting. That's fine. We can take that and print that out. So you can see that gets, when we print that with our AE table, we get something that looks like this. Those n percents look pretty good. They're all n percent. It's a bit busy, a bit hard to read, but other than that, it's probably fine. So let's make it a little bit easier. So let's put in all of the other information that we need for our T-format. So to make it a little bit easier to read, let's put in the group and the labels and the sorted columns. So we're going to see adding the group as row label 2, because that's this one. That's why it looks so busy. Then we have row label 1, which is the actual problems, and then our sorting columns as per order 1 and order 2. So once we make that, we're making a new T-format object called order AE. And when we do that, we get something that looks like this. This looks like so much better. I love this, right? I can see I have any body system, then I have cardiac disorders. This looks really nice to me. I'm pretty happy with that. So the next thing I'm going to do is I'm going to get rid of these order columns because I don't want them. They are not pretty to look at, and I'm going to add a title, which is just what it says to do for step C. Once I do that, I get something that looks like this, which I would say is pretty darn close to exactly what I would like. Okay, so with that, I think we are good to go. Ellis, do you want to take over?
I can do that now. So I think we've done a lot of great things so far today. We've learned a lot about TFormat and how those tools work. We got a lot of the basics of how they function. But as with TFormat, there's a lot of advanced options that we have with TFormat that we've built out over the last, what is it, 6-9 months or so. So we want to go through and hopefully share with you to answer some of the questions that y'all have asked in Slido that we said, oh, we'll get to it later. Now is when we're getting to it. So what we're going to do is we're going to start first with loading a bunch of libraries. First Tidyverse, Haven for loading in our data, TFormat, and the GT and GT extras. These pieces are for some really cool functionality down the line. We're going to load in our ARD. In this situation, we're using, in the past two examples, we've done a demog table and an AE table. Those are relatively simple, just long tables, but we all know that not all our tables look that way. They're not all just simple, long, kind of big tables. Sometimes they're a little bit more complicated. And so this is a model that is generated on the data. You can see the code that's included in the repo here. I believe it's under dataset code. And you can look at how exactly model XPT is made in the make ard.r script there. But essentially, this is an MMRM model, I believe. I'm not the one that built this. But it looks a little something like this. So we ran a model to look at the differences between the treatment and placebo at the various weeks, and it would give us some model estimates for the adjusted mean and the standard error for both the treatment and the placebo, as well as some model results as well. So like the p-values and the estimated difference and whatnot. And so we have this table built up. We also have, and this is not something that we have seen before, if we do a tail, we have these big N params as well. So we'll be getting to those and finally showing you guys how to deal with big N in your ARD. And so big N is calculated and then tacked onto the ARD. So let's take a quick head of our table and let's start building out our TFormat. And so the first things that we want to fill out are the basic columns that we'll be handling with our metadata. And so the first thing we want to fill out is groups. So what are the groups that are on our rows of our table? And so this is the model results category column. So if we do a primary table $sign model results and do a table on that, or let's do actually a unique. These guys, we can see that there's 3 different values. There's model estimates, contrast, and NA. NA comes from these big N down here, which we already knew because we saw that down there. But generally, the 2 groups are model estimates and contrast. Next, we have labels. So remember, label defines what are the row names of our table. In this situation, what are we trying to show? And if we go back to our head of primary table, we know that that is measured because by row, we want to present the adjusted mean, the standard error. Let's just do a unique primary table measure, difference, p-value, and confidence interval. Next, we have to determine what are the columns of our table. In this situation, we want to be showing visits and treatment across the columns. And so this is the way that you would do this. So we have our visit column right here. If we do relook at our head of primary table, so we have visit. And so we want that listed at the highest level. So we list it first. Then we have TRT, which is the treatment, which is either the treatment or placebo. And so what this is saying is we're going to have visit spanning across the various treatments. And so it'll be visit 4 at the very top, and then in the order in which it's printed in the table here, GSK 1, 2, 3, 4, 5, 6, 100 milligrams, then placebo. And then it'll go week 8, GSK 1, 2, 3, 4, 5, 6, 100 milligrams, and then placebo. Param is the param. So this is defining the value, like what type of value this is. And then value is the value column. And then finally, we have the sorting calls. And so in the past examples, we have one or a couple different ords. You can really name this whatever you want. In this situation, we are going to be just have this one ord column. So that is creating the start of our TFormat. Right now, it doesn't really do anything. It doesn't calculate much. I mean, we could try to throw it into to print, but it's going to be just a very ugly table. So we're not going to spend our time doing that. One thing I want to note, and we didn't touch on this before, is the way that TFormat works is it looks in your environment to figure out what it should be dropping into the params right here. So right here, you may notice that we were able to write these as unquoted variables, which is very like tidyverse-esque. Oftentimes, you'd have to put quotes around these. But we thought that it might be nicer to set it up so that you could just type, I want model results category, and it would handle that for you. The downside of this is if you have another object in your environment that has the same name as the unquoted column that you're trying to use, it's going to respect what's in your columns. And so, or in your environment. And so when you create this fake object, we're going to call it 1, 3, 2, 4, 5, 6, and we create this TFormat, and we pull out the column entry of TFormat, you can see that it actually kept the value 1, 3, 2, 4, 5, 6 because it's respecting what's in our environment. A safer way to do this is to use quotes, and TFormat recognizes, oh, you use quotes, so this is exactly what you wanted to be passing to me. And so then it'll keep that value. So the benefit of this is you could potentially predefine these entries elsewhere. So you could have code that is reading and pulling in values from like a database to construct your TFormat for you. And so it'd read them in and construct the TFormat and drop in fake object being the column I care about. That's a string. And then when you enter this in here, rather than keeping fake object, it'll respect it. And it's now the column that I care about that you read from your database. And so that is kind of the nice benefit that we have by doing it this way. And that's why we left it and why I wanted to share with you why we chose to do this. So now that we have the columns generally selected, let's go through and define the body plan. So once again, body plan is defining to TFormat. This is how I want the contents structured of each individual cell. So let's take a quick distinct of the param. So we're going to take primary table, pipe it into distinct, and get the different params that we have. So we have estimate, STD error, p-value, conf-flow, conf-high, and big N. We know that big N is going to be used later. So we're going to kind of ignore that for now. And we're going to do this filter out big N. We're going to group by the treatment and measure, which are our rows and groups. And we're going to do a quick summarize to combine which parameters are falling under the treatment and measure columns, which are our group vals and label vals. So if we run that, we see that, for example, standard error falls under the SE measure for both treatments. I guess it isn't treatment, it'd actually be the model results category. Excuse me. Run that. So yeah, excuse me, SE is under the model estimates. That conf-flow and conf-high are both listed under the row name 95 CI low high. So we know that we will have to do some sort of FormatCombine because you can't have these two show up on the same row and not have them combined together. The way you construct a format structure is you have your group val. We use .default. The reason it's a dot, somebody asked this earlier, is the dot adds the probability of being unlikely to actually match a value that you have in your group val entries. You see this is pretty common in tidyverse. If you're using like summarize, they have a .keep argument after you enter all the columns, and it allows you to identify whether you want to keep your grouping or not after summarizing. But the reason they use a .keep as opposed to just keep is keep has a higher probability of being like a real column name in your data set. And they want to make sure that you're able to distinguish between the column or the argument .keep and the column keep. So that's kind of why we did this. And so what this is going to do is we're saying for every group value and for every label value, that's why it's .default, convert the estimate param to round to 4 decimals. Then we can, again, we can add more information here. So what this is saying is for every group, but for every label value of, for example, of week 4, round to this. So we're able to add layer on information in our format structures, in our body plan, to add more information so we can fall back on a format, but then go, well, but actually in this situation, I want to do this, and without overriding the older, more general descriptions. With a FormatCombine here, this is something we're actually going to be using here. We are saying for every group and label, if you see conf high and conf low, format it in this way, where you're going to round these both to 4 and combine it so it's square brace conf.low, comma, conf.high. As you saw, we can add in Unicode or whatever we want. So it's actually pretty flexible, but it's going to respect any strings you put that's not included inside of the curly braces. And you have to define the groups here, or the params there, otherwise it doesn't know how to handle that. So let's start building up our body plan for this more advanced table. We're going to pipe in, because we already generated primary results TFormat. I don't want to have to rewrite that every single time. So let's pipe that into our TFormat. In this situation, we're only going to be defining body plan, because we already have the other columns defined earlier. And by default, I'm going to add a standard, like if you see a value and I haven't done anything to it, just do this to it. And so this is, this is saying is by default, so group val and label val being default, just round it to 2 decimals. That's fine. I think that'll get me where I want to go to for the most part. Now I'm going to add more specific formatting for the various groups and labels that I have. And so for the group val model estimates, and if I have the label val adjusted mean, what I want to be doing is rounding to 4 decimals when the param is estimate. When the model estimate, or the group val is model estimates and the label val is SE, I want to round my std.error to 5 decimals. And so this is, adding more information, building it up as we go. We're going to then, for the group val contrast, so these are the standard model estimates that we are able to pull out from our model. Now we want to actually know what is the difference in our treatment between placebo and the treatment that we applied. So here we have our contrasts group. For difference, we want to be rounding to 4 decimals, and then we will be combining the 95% confidence interval for that difference in the next row. And so that label val is 95% CI, low high. And in this situation, we did it a little bit differently. We have conf low and conf high. And because we want to be rounding them the same, we just drop in just a format. We're not going to add additional information because we're rounding them to the same amount. And so that's maybe a way that you can cut back a little bit with your formatting. So let's build that up. Now we're going to run this. I'm going to filter out big N so this print to GT can work for us. So let's run that. It's going to take a second to run because Zoom is taking a lot of my resources. There you go. We've got our first look at the table that we're trying to generate. It doesn't look too terrible. We've got still this ORD column that we've got to keep around. We've got the adjusted mean and standard error floating around here. Excuse me, that should have parentheses in there. So let's rebuild that guy. We've got a difference. We've got our 95% confidence interval and our p-value. But as you can see, our p-value fell back on the default rounding of just rounded to 2 decimals. We don't want that. So how do we handle conditional formatting? Christina talked about that a little bit earlier. But conditional formatting kind of gives us the ability to look at the value itself and go, all right, now how do I want to handle this? How do I want to present it? Importantly, it's only ever going to be based on the value that you're trying to format. It can't be based off of external values. So it can't be based off of, well, if difference is greater than 15, then I want to round p-value to this. That's unfortunately not how it works. It has to be based on the specific value that you're trying to be applying the formatting to, which I think makes sense and is in line with what you might expect for other formatting tools. So you're formatting the contents. And so this is how you construct a format when. It has a left side, which is a comparison against the value you're trying to format. It's as a character. That way you can enter like the greater than and equal to without R barking an error at you. And then the right-hand side is either a format that you want to apply or a character value that you put in when the left side evaluates to be true. And so in this situation, what I'm saying is if it's greater than 10, format it and put the have the 2 values dot and then the last one. If it's greater than 1, only put in the first value. So in this situation, if I'd changed it so it was like this, any values that were less than 10 would have a space in front of them because I'm saying I want two character spaces at the very beginning. In this situation, that's not what I want. And then if it's less than 1, let it bring it down to 1 value in front of the decimal, 2 values afterwards, but then add asterisks around it because maybe that's important to me. And then finally, if none of these are true, none of these evaluate to be true, put in the text missing value. We can actually see what these formats look like if we use the apply_format function and we pass to format def the format that we want to apply. We do have to pass a tibble that we want to be formatting to. And then we pass which column we plan on applying this conditional or this format to. And so what we're saying here is that we're going to be applying this format to the column X of this dot data. And that has the values 11, 9, 2, 0.005, and NA. So strangely enough, it matches with all the conditions that we have in this format one. It's like I built it like that. And as we can see here, we now get 11, but now it's a decimal. We get 9, but it also has a decimal. 2 also has a decimal. 0.005 is less than 1. So it now is rounded to 2 decimals. It has the asterisks. And then NA, none of these 3 conditions above are true. Therefore, it falls on this one, which then prints missing value. So now that we have an idea of how this conditional formatting works, let's add that into our p-value. And so we know that when the p-value is less than 0.001, just display the string less than 0.001. If it's greater than 0.99, we want to display greater than 0.99. But otherwise, if it's not either of those situations, just round it to 3 decimals because that's the level of precision that we want to be having. So we can print that out. We're going to once again preview what this looks like, filtering out big N because we haven't addressed those yet, and that will have it throw some funny errors. So it's running. And now we can see that p-values, rather than being rounded to 2 decimals like they were before, all our p-values are very low. And so the only condition that got met is that they're less than 0.001. Therefore, the string that gets dropped in is less than 0.001. Are there any questions at this point that we should be aware of, or are we good to continue?
No, people have been quiet. But if you do have questions, put them on Slido.
Yeah, please let me know if anything that we're talking about isn't clear. There is a lot of information here, but the idea is that we're trying to provide a lot of flexibility to you so you can change them as you want or need to.
I
So
will
now
also
finally,
add, before we go into big ends, like everything that Ellis has just showed you, there are vignettes about on the TFormat website. So like, if you're like, this is all great information, but I'm half taking it in, and that's totally fine. There is like proper vignettes that you can look at later. Sorry, Ellis,
yes,
continue.
yes, we did make a lot of effort to make sure there's lots of documentation for you. Hopefully it's not an overwhelming amount of documentation or you don't know where to look though. All right, so big ends. So we did get a question around this specifically of how do I add in the number of participants that were included in the trial at this specific time point or in the treatment or whatever, depending on the table that you have, rather than having to just add like another row to the table of N participants or something like that. So let's take a quick look at the big N data set here. So what we have is this is in our ARD, there's no entries for model results category or measure, and that's because they don't apply to the rows. These are going to be applied to the columns. We add another layer to our primary results TFormat BP2. Excuse my naming convention, where we're going to add TFormat, and the argument in TFormat that adds big N is big N. You know, we tried to give it a reasonable name here, and it takes a big N structure. So big N structure takes two entries, the first one being what parameter defines the big N param. And so in this situation, it's just big underscore N. It could be any string that makes sense to you and your organization. Next, we have the N format. So then how do we want to be formatting this when it gets added into our column names? By default, it's going to be, or I forget what it is by default. Yes, it is just going to say, it's going to print it on a new line and say N equals XX. In this situation here, we don't want that. We do want a new line, which is what the /n is saying. But then it's saying we want it in parentheses, N equals XX. And so this is going to make it so that it's always going to be at least 2 characters wide, but if it's greater than that, it's going to allow that. In our scenario, we have 100 participants, but when we set up the ARD, we did filter out 1 just to demonstrate that it does change. So now we can add that in. And just like that, bing, bang, boom, we are able to have a table that not only has all the values presented nicely, but we're able to print out the number, the big N, for every single grouping here. And so you can see in placebo, we dropped a single person just to demonstrate that the value changes for these different formats here. One other thing to note is the way that we set these up. And so the big N cares about the values you have in the columns. And so the columns that we set up for our TFormat were visit and treatment. And so because we had each of these defined, it goes down to the lowest level. And so because we have week 4 in GSK 1, 2, 3, 4, 5, 600 milligrams, this value of 100 gets applied to this lower level treatment at week 4. If we only had visit defined and no treatment, this would then get assigned to this upper level week 4. It will complain if you have multiple values listed, as in you have week 4 listed twice, and I don't believe it allows you to specify only treatment and not visit. So there's like a minimum level of information you need to provide, which is the highest level, and then going down, you can potentially put in, not include that information. But I digress. So then, now that we have these big N's, these columns aren't exactly the way I want them to be. So let's look at how I can order them, because we've got ORD, and I know some places like to list placebo first and then the treatment. It really depends on what you want to do. And so the way we can go about doing this is using the call plan function. So call plan takes, it behaves very similarly to the dplyr select function, but by default, it's going to try to follow the last identified model. So dplyr select follows the first identified principle, which is the first time that it sees that you selected a column. It goes, great, I've seen that, and it's not going to respect any later on selections. We wanted to allow you to specify potentially a column a couple different times just through the selection process, but the last time you identify a column is what it's going to try to respect. And so we can go through this and look at a couple different columns here. So this is, what are the columns that, what am I doing here? Visit and treatment. Okay, so this is telling me what are the columns that exist now that I pivot wider, because we said visit and treatment were the columns. And then what were the column names of the original ARD that we have, since we do keep up some of these and we pivot wider based on visit, treatment, and visit. And so we're going to, once again, pipe our big N. So now that we've got everything else defined above, we're going to pipe into another TFormat, and we're going to use call plan and define it using the call plan function. What we want to keep are the model results category, which is our group. We want to keep measure, which is the row labels that we want to be keeping, or that we're going to be using. And then we're going to use this function, span structure. So some of you may have noticed, or we've talked on this a couple times now, how we have these spans going across this. And standard tidy select semantics kind of breaks down if you have multiple column headers. It's kind of, it wouldn't, how would you go about identifying this? You could use regex, but that kind of gets a little complicated and weird. And so we wanted to provide a way to make it really easy for you to say, this is the exact column that I want, even if there are span structures involved. And so the way you go about doing this is you use span structure. The argument is the name of the column in the ARD that you're wanting to select from. And so in this case, it's visit. And we're going to be selecting week 4, week 8, and week 12. And that is the order in which we want them to show up. We want it to go week 4, then week 8, then week 12. We don't want it to go week 12, then week 4, then week 8. That just kind of doesn't make a whole bunch of sense, does it? Next is the treatments. And what this is saying is under each of these visits, this is the order that I want this to appear. So I want it to say placebo first, and then the treatment that I want to have. And then we're going to add this subtract starts with ORD. So then this is going to remove the ORD1 column from our data set. So we can print that. And we are going to compare. What is this one doing? So this is basically what we just had before. And then this is the new one. And you can see once it runs, it'll have the new order that we care about, where now it's placebo and then GSK 1, 2, 3, 4, 5, 600 milligrams for every single visit. And so that's the order in which we wanted it to show up. And we also removed the ORD column. Now you could, potentially change this up if you wanted to. Let's go a little bit rogue here and type these in and change the order so that it's actually going to be show up like this. And so we're actually going to remove week 8 here and then leave week 8 in this column. So now what we're saying is we want week 4 and week 12 to show up as placebo and GSK 1, 2, 3, 4, 5, 6. And then we want, let's mess this up even more so we can really tell what's going on. And then we're going to have treatment and then placebo. So let's run that. Oh, I forgot to put a comma in there. That is my fault. Now it's going to switch up the order on us once it actually produces the table. And as you can see, we have week 4 and week 12, like we defined it right here. And then we have week 8. And then we have week 8 show up over here. And then we wanted it to show up in a different order, which is why we needed it in a different span structure to make it show the treatment and then placebo. Not sure why you'd want to do it like this, but we wanted to make sure to provide the opportunity for you if you had multiple different span structures. Your table could get rather complicated potentially. We wanted to provide that functionality for you. And so now you can see that the treatment is listed first under week 8, and then placebo is listed second, exactly how we said it should show up in the call plan. All right, so now we're going to talk about the row group plan. And we've talked about this a little bit now, where we have the groups of model estimates and contrast. And what we want to do is we want to put a space between model estimates and contrast. We want to visually kind of separate those a little bit more than just the empty line under contrasts. And so the way we do that is using the row group plan and a row group structure. Christina talked about this a little bit earlier. And by default, we indent them, which means the label locations, these are indented. Christina also talked about that a little bit. So we're going to leave that as is for now. We're good with that. Oh, excuse me, that's to demonstrate what's going on. And then here, what if we actually wanted to add a break underneath model estimates and model estimates only? So that way there's no spacing under contrasts. It's just under model estimates. So the way you go about doing that is you have your row group plan, you have your row group structure, and then you specify the group val is model estimates. This is very similar to what Christina did earlier. And we're going to set the element block Postspace to be just a single space there. So once again, we can run that. And so remember, see how all of these are building up and layering up. So you don't have to define everything all at once and have this massive TFormat that has all these different things. The idea is that somebody in your organization goes and kind of defines a TFormat early on and going, this is how we want our AE tables to look like, or this is how we want, I don't know, MMRM table to look like, and this is how the ARDs are supposed to be looking like going into it. And that way, you don't have to write as much code in order to get the table that you're intending. You're able to take in the ARD, QC that, throw it into our TFormat or into your organization's TFormat, maybe do a little bit of tweaking based on, there's always going to be slight differences in the study, and then you can get the result that you're intending. Let's quickly demonstrate this with an underscore, or so a line, a dashed line showing up underneath them all. And so yeah, this is working out pretty well. This is looking like we want. And once we drag it out, we can see we've now got the lines underneath this, just like we were hoping for. The next piece that we have that somebody did bring up is headers and footers. Headers, there's the titles and the subtitles, but footnotes are a little bit more complicated because there's a lot of differing ways or different places you might want to put a footnote. And if you want to add it so that it's putting an asterisk or a symbol next to something in your table, you need a way to define that. And so the way you go about doing that is using a footnote plan. And so the footnote plan takes a series of footnote structures in the mark that you want to be using. And so footnote structure defines the text of the footnote and the location of the footnote. And that is based on the group, label, and columns that you want to be using. If you only specify one of those, so if you specify only a group, that will put the mark next to the group label in your table. So if you just define, for example, group is model estimates, it'll just put it on the model estimates here. If you define a label, it will just put it on the label. So if we specified adjusted mean, it would just put the mark on the label. And if you just define a column, it will put it, based on what you define, on the spanner or the specific column content, or the lower column. But if you define a combination of the two of them, or a combination of group, label, and column, it will then shoot it down into the actual contents of the tables. So this allows you to define, I want a footnote on week 4, GSK 1, 2, 3, 4, 5, 6 at difference. So say you wanted to put an asterisk on this entry to provide a little bit more context. That's how you go about doing that. So let's go through and add a couple different footnotes here. So the first one we're going to add is going to be on both of the group values that we have here. And we're saying the estimates are based on an MMRM using an unstructured correlation matrix, allowing distinct variance for each visit. We have our footnote structure, we have the text here, and then we're going to define which groups we want this to be applied to, because this is going to be applied at the group level. And so we pass a list that takes the name of the column from the ARD, and then the 2 entries we have here. And so this is model estimates and contrasts. We don't have a .default in this situation because we want to force you to have to specify exactly which locations you want to apply this footnote to. Next, if you wanted to add a little bit more information and add this to a specific row label, you have to specify both group and label. And so you're going to specify, you can. You don't have to specify group in this situation. It'll allow you to specify just label. But if there is a situation where you wanted to specify a specific label in a specific group, this is how you do this, where once again, you have model results category, the name, the ARD, and where that value is contrast. And then for the label value, where measure, which is the row label column, I want it to be applied to the P- value. If you want to apply it to the column, you pass a list, and this allows you to specify, once again, without using like a span structure or something like that, I want to apply to visit where it's week 8 in the treatment of GSK 1, 2, 3, 4, 5, 600 milligrams. And so it's now going to add the special footnote to demo, calling out a column. And finally, calling out a specific value in our table, we specify both the column and the row or label that we want to be applying this to. So let's run all that. And let's see what our final table looks like with all this TFormat generated and applied and created. And it takes a little bit to run. That's just my computer. Let's print out the TFormat now that we applied it to primary GT. And there we have it. So now we have our footnotes. And so we can see here, the special footnote to demo calling out a column is 1, and that is assigned right here. So the week 8, the treatment column, which is exactly what we wanted. The estimates based on MMRM are supposed to be applied to the group labels. And what do you know? That's where they are. Number 3 is supposed to be applied to a specific label, p-value, and there it shows up. And then finally, calling out a specific value, it's supposed to show up on week 12 for the treatment column, or for the treatment GSK 1, 2, 3, 4, 5, 6, under the label value p-value. As you can see, boom, there you go. It's been applied to that specific cell in our table. And so that allows us to have a little bit of flexibility when we generate our tables and apply footnotes to this. This is all pretty dandy, but we've gone through, we've done all this work to this TFormat now, but we want to submit this to a journal or something like that. And they don't accept p-values in this. Hey, if it's less than 0.001, you can just drop the string less than 0.001. No, they want to be accurate. And so what they want to do is have you provide scientific notation for any values that are less than 0.001, so it's easier to read. They don't want it to go out into infinity and have it be a really wide table. And so what we could do is we could go back and go and rebuild this entire TFormat step by step like we just did. And I know I'm talking through and trying to explain this all in a lot of detail, but we've just spent the last 40 minutes doing that. I don't want to do that. But you can just layer on a new body plan element that's specific to that p-value, and that will only change the p-value for you and it won't change any other elements of your TFormat. And so we're going to add a body plan. We're going to update this format structure to apply to contrast and p-value, and update that p.value value param. So these entries here. And what we're going to say is, hey, when it's less than 0.001, what we actually want to be doing is print out to 3 decimals like we were doing. But this time we're going to set the param or the argument in format scientific. What scientific does is it adds the ability to use scientific notation on our formatting. And what we're saying here is put it as x to the times 10 to the whatever value. And all the other situations, if it's greater than 0.001, just put the normal value in there. So now we can update this. We're going to reprint it and reprint out this table. And we'll give this a minute now. This is my computer, not the code. That's taking a while to run. And as you can see now, the table is the same. The table has not changed in terms of it still has the footnotes, it still has big N, it still has the column order the way we wanted it to be. The only difference is now this p-value, as opposed to just having the string less than 0.001, now has the scientific notation that we wanted to be using per some journal that we wanted to be submitting to, without having to go through this whole process of going back to our atoms, rederiving the values, and recalculating this, and having to rebuild our table from the beginning. We just updated this one format structure, or we just added to it, and it was able to remake this table for us with very, very little effort. And so that's supposed to be like a real nice advantage of TFormat. Next, because we outputted a GT, we get all the benefits of a GT table as well. So we can go and we can take this table and we can use the GT extras package and apply a theme to it. So we're going to add the GT theme Guardian, which is from the Guardian. Then we're going to add a little bit of table cell styling. So we're going to use GT tab style, so table styling. What we're saying is we're going to work on the cell text, so the contents of a cell. We're going to make it red and we're going to turn it italic. In the specific cell we're going to be working on is the columns where it is week 12, and the rows where the measure is p-value, because it has not collapsed these columns or these rows yet, so it's respecting that. And so we can print that, and using GT, bada bing, bada boom. And this is now GT, so none of the values are actually going to be changing. This is just applying theming in GT. And so we can be confident that the values aren't going to change because there's no reason to have changed. We're just adding styling to them. And now this p-value for week 12 is highlighted red, because maybe that's the main result that we want to be pulling from this. And it keeps all this styling for us. Okay, this is wonderful as well. But this is just like in my console. And we all know that just leaving these tables in our consoles does not, we need to do something. We need to export, we need to share it out, right? We need to save it to a PDF or an HTML, for example. And we allow GT to handle that for us as well. So GT comes with this GT save function, and you just pass the path of the name of the file that you want to be creating. And then you can optionally pass the directory, so path. I want it to, by default, just print out into my local working directory. So we can run this, and now this is going to be generating a HTML document. I can now see this inside of my folder here, and we can see the primary results.html. We're going to view this in a web browser. And this is exactly as we previewed it in our table here, where it has all the contents, it's styled, it's got the cell here. But we don't usually use HTML to submit or put into our systems. So one thing that we worked with Rich, the author of GT, and we added the ability to save out to docx. And so this is our Word document. So Word documents end in the docx extension. And so now this is going through and going to be saving this to a Word document for us. Let's open this up now. And this is going to appear exactly, more or less, this doesn't have parity to the HTML output, but it's going to format it the way, more or less the same way that it should, as you would expect it to in a table here. So we've got all our rows here. We've got the styling for the cell here. We've got all our footnotes and all those highlights there. So this is exactly what one might expect for outputting to a Word doc. Isn't that awesome?
I'm gonna, Ellis, before you move on, I'm gonna just, some people have some questions about pagination. Do you want to talk about pagination? As we've now looked at some things that are pages, rather than pagination only comes along when you leave HTML, because HTML has no pages. It can be as long as you want, but docs are different. So Ellis, take it away.
Totally reasonable. So by default, I mean, we can add in a bunch of rows here. So it does not, or I don't want to actually go through the effort of adding enough rows. So by default, it will split these across pages. So I'll just kind of go through and just keep on clicking here until it does go actually down to a new table. That'll take a second here. So it does paginate in the sense of if the table is longer than an actual page, it will repeat, almost there, it will repeat the headers. However, it does not have the ability at this point to allow you see how the column names are repeated. And so we're good with that. It does not have the ability yet for you to define how to be splitting it across multiple pages. That is not a feature that exists yet in GT or in TFormat. If there is enough demand, we can definitely work on adding that. We have some discussions actively going on in the GT GitHub discussions page to discuss how that might work. And then I'm going to be probably meeting with the developer, Rich, at some point to talk about what that might mean, or efforts around that. But if that's something that you want, we really would like to hear if that's a game-stopping feature or not for you. If it's okay to let Word kind of handle the splitting for you, then you're golden and you don't need to do anything. But if you want to make it so that you're able to specify the page splits, I think we can do it. It's not a matter of whether we can or cannot do it. It is whether it exists yet in GT or TFormat, and at this point, it just doesn't.
The other thing, just another question that got put in is, can you define landscape versus portrait?
Actually, I don't think you can at this point in time. We could definitely, once again, it's a feature that if that's something you want, we can talk to Rich and get that added in as a feature. I know how programmatically to tell Word to do that. It's just not something we've thought about adding yet. But we definitely can. And I think RTF outputs do support landscape output. It's just we haven't added that into Word. We're adding these features in.
And so, yeah, definitely. I will put a link in the chat here about where to go and have that discussion, and add to that discussion if any of you have strong feelings about what you would like to see. RTF, I think, is slightly further along than Word in terms of some of the features, like putting the titles and stuff in the top left and things like that, and getting the page numbers in. But
yeah, it does support titles, so you can let's add this in here. Title equals my title. Let's call that alt2. Helps if I add a comma in there. It does at this point technically support excuse my computer as it complains a little bit trying to run Zoom and then do this. It's not super happy. Boom, boom. Okay, we're going to out to primary results 2. It does support titles and footnotes and span headers or source notes and whatnot. So a lot of the features in GT right now are already supported. It's just not the breadth.
The other thing that you can do if you want to see these, even if you don't really have anything to like particularly add, how discussions work in on GitHub and how kind of Rich helps prioritize what things should be done is you can add a little like upvote it and say like, I also care about this problem. So feel free to also just like upvote it and say that you care.
Yes.
GT isn't just for pharma. So if we as pharma make a lot of noise, we get the stuff we want fixed. If we don't make a lot of noise, we don't get stuff we want fixed is kind of the rule of thumb.
Interesting. I think I messed it up. I trust me that it works. I don't want to go through the effort of making it try to work again.
I will also say though that somebody asked if there's paging, if there is pagination, would you have to do it a bunch of different times in terms of like apply a TFormat for each page? And the answer is no. The plan would be that we would handle that and help split it out for you. There's kind of a debate of exactly where it makes sense to put in the pagination and allow you to specify your own. And that's what we're just trying to decide right now. So it's definitely in the works.
Yeah.
It's just not quite there yet.
Are there any more questions or?
No, somebody asked about WebShot 2. You do need to install WebShot 2 if it's that things are not working for you. It's just a GT requirement that we just didn't install for now because we didn't need it, but that's really
yeah, I think you only need WebShot 2 if you're going out to save a PNG.
And a PDF apparently.
And a PDF, yes. Because the way the PDF works is it generates an HTML page, screen captures it, saves it as a PNG, and drops it in your PDF. Or no, it screenshots it and saves it as a PDF, excuse me. No PNG middle ground. But
we didn't install that because it's not necessarily required for everything. So it was just based off of the install that you have in your RStudio Cloud. So that's all you need to do.
Yep.
Okay, continue along. No other questions. You're good, Ellis.
All right, perfect. All right, so the last thing and the last really cool feature that I want to show you about TFormat is how do you generate mocks. So everything we showed you so far has been assuming that you have your data, you have your full ARD already set up. But we all know that that's not typically how the world works, that oftentimes you need to have a mock describing what table you're going to be making. Of course, why we do that, but we do. So we have this handy dandy function in TFormat called print mock GT. And what that does is it accepts a TFormat, and then it can accept some data. But importantly, it does not have the value, whatever column you defined in your TFormat to be value, it does not have that. And so you're able to run that, and it's going to use TFormat and all the information you've passed to this TFormat to figure out what a mock might look like. If you pass, for example, the ARD, because typically an ARD is probably going to be pretty well specified ahead of time. You should know what an AE ARD should look like. So you can probably create that ahead of time. And you can print your mock GT. Print your mock GT, and now we're going to preview it. And this is what your mock looks like. It is it's using the values that you passed to your formats where, we have the x.xx or the square brace and whatnot. So it's using those values that you're trying to define, your rounding and whatnot, and it'll drop those in for you. And there you go. You've got your mock already prepared. You don't have to, spend time in Excel trying to move things around or in Word documents or whatnot. But I kind of cheated because I already had the primary table. So you could go through and generate it yourself too, because like I said, you probably know generally what your ARD should look like or the general contents for your study. So for example, here we know that we're going to have placebo and GSK 1, 2, 3, 4, 5, 6, and we know we're going to have visits 4 through 12. We know that row-wise, we're going to have model estimates, estimated mean and standard error for our model estimates section, which is this top piece of our table here. And so we're going to cross that with our columns to generate some mock data there. Same idea for our contrast section of the table, where we know that we're going to be sharing a difference, 95% confidence interval, and the p-value. And we know the parameters, because we'd split them row-wise, will be estimate, conflow, confi, and p-value. So we can combine that together and do a crossing. And we know that this will only be applied to the treatment column of GSK 1, 2, 3, 4, 5, 6. So I just throw in this filter here. We know we're going to have some big N, and they'll be available for the lowest level columns. So we're going to add those in as well. You can bind them all together to create a nice long data set that describes all the contents that we expect to see without having any values already defined. And you can see how quickly I was able to build this up. And this will then give us our mock GT with this is going to look identical because I built this up to look identical. So we probably won't see much of a difference here with this. So you can see that we have our placebo, all the contents for our table showing up exactly how I want to. But TFormat also has a nice party trick, along with just allowing you to make mocks kind of define, here's the rows, here's the columns that I expect, and the parameters that I expect to be dropping in there. Given a TFormat can try to guess what columns you might be having and produce a mock without you providing any data whatsoever. It's not necessarily going to be as accurate, like it won't necessarily have all the content that you're expecting because it's just guessing based on the TFormat that you've defined. But as you can see here, we've got basically the correct table, right? I mean, this is a little bit off because it was guessing and it used the column names to say, well, I think you're going to have like 3 different categories for model results and 3 different measures underneath each one because it's guessing. But it did know that the columns you're likely to have are week 4, week 8, and week 12. And these are the treatments, placebo, and GSK 1, 2, 3, 4, 5, 6. So it was able to guess that, and then it was able to add these in because it saw the row level information from the body plan. And so because we were so explicit with our body plan, it was able to come up with a good idea of what rows we might be including in our data set. And so that is mocks using a TFormat. And I think this is really, really fun and exciting. And I think that this is kind of a really cool piece that'll help us transition into using TFormat, because not only does it style the ARD for us, but it allows us to not spend, I don't want to say waste our time, but not spend our time as much on the mock and focus more on what are we actually trying to create. So that's mocks. So now we're going to go into closing out. I need to open up a PowerPoint, so that's why I'm stopping to share my slide. Are there any questions about mocks right now before I move on?
Don't have any of the slide up, but you can raise your hand and I will unmute you. Oops, I think one popped up. If we have more than 3 visits, say, how can you handle that with your template program? So I am happy to answer this. Basically, you have a couple of options. Option number 1 is do what Ellis did and showed you and just like make up some data. If you make up your data and give it fake data, it will work with the fake data. And you can just put in all your visits you have in that. If you don't have fake data and don't want to make fake data, there is a option called n_calls, which will let you change the number of columns you have. It's It's not very smart in that like that one number is used for literally everything. So it will, that's why we'll give you like default 3 columns and 3 groups and 3 everything. So if you change that number to whatever number you want, it will try and do that for you. So it tries to be a little bit smart, but yeah, it's not the most brilliant thing in the whole wide world, but that would be how you would change it if you were really desperate. I would probably recommend, though, making up your own data, just because it will be the most accurate to what you're wanting to do. So can you use the mock template for an ARD formatting in the future? Yes. Once you make an ARD template, once you make a TFormat, you can apply it as many times as you want. So with one TFormat, you can apply it to 10 different tables. If you have 10 different tables that all look the same, and you just swap out what's in your data section of your print to GT. The idea definitely would be that you would generate your mocks at the beginning of your process, generate them using TFormat, save that format, and then apply it later on when you're actually ready to make your tables. And that way you can kind of take some of this formatting off the critical path. And you're doing all the formatting you want to do when you're making your mocks right at the beginning, and you don't need to worry about doing it later. One of the things that's currently not available, but is on the very high on the to-do list and will be available hopefully by the end of this year, touch wood, is the ability to write these TFormats out to JSONs. If you look at them, you'll be like, this looks kind of like a JSON. You know what a JSON looks like. So the plan would be that you would be able to write them out to a file type and save them, and you can hoard them and do whatever you want with your little JSONs, and then read them back in and apply them when you're ready. So that is the plan, but for now you just need to keep the code, which again, it's not that hard to keep the code. It's easy to keep code. So yeah, with that, Ellis, those are all the questions we have.
Excellent.
Another question. Wait, 2 more questions just popped up, or another question. No, 2 more questions. With more output columns, will split on page 2. Would you be able to provide an example of splitting column outputs?
I mean,
we can try.
Probably work on something to do. I don't think we have anything right now. We don't have any splitting by capabilities right now. I mean, if your tables are that big, that's a design thing, but could probably provide some sort of examples on how you could handle tables that are, 20 columns wide and therefore don't fit nicely in your Word documents or PDF documents. But I think that's kind of down to like how you format your tables a little bit.
Yeah. So TFormat basically we don't have something specific for how it works, and potentially it might be an issue with GT, but we'll have to see what GT does. I don't know what GT does. So I think I'll probably answer. Anyway.
Alrighty.
That is all the questions.
So ready to hop into the last little set of slides before we pretty much close this thing out?
Yeah.
All right, we'll do this and then go from there. All right. So thank you all. You've now heard me drone on for about an hour or so. We're almost done. So let's have a little bit of a retrospective. What did we cover in this workshop in the last, we've been together for a little over 7 hours so far. I hope you learned something. So the first piece is we talked about atoms. We talked about how do we create atoms from SDTM. We use tools like MetaTools and MetaCore and Admiral to take these raw-ish data, and make it into standardized atoms. We have ADAE, ETTE, and DeMog tables and whatnot that we're able to take, and it was a lot simpler than maybe having to code it by hand. Next, we performed some analysis. We used tidyverse tools as well as tplyr in order to take these atoms that we generated and turn them into a nice ARD. The ARD giving us the ability to store our data in this longish format. So we're able to clearly define where everything goes, but importantly, not format our data yet. which allows us to go back and perform QC and make sure that the values, which is what we really care about, are correct. So we can then focus our time when we're producing our outputs on making it look nice as opposed to trying to make it match when we do our QC process. Then we use tools like TFormat and GT in order to take these ARDs that we generated and spent so much time creating using tplyr and tidyverse in this long format. We're able to make them into a nice table that we're able to view really easily and quickly, reuse these TFormats later on so we can reduce the amount of effort overall. There's a little bit of upfront cost, but once you have several different TFormats already built up that you can reuse across your AE tables and your MOG tables and whatnot, you can just use this across multiple studies, and it nets you less time, or uses less time. And then because it's going out to GT, we're able to take advantage of all the really great tools that GT has. You can do additional styling and formatting specifically on your table that you maybe couldn't do normally with your in TFormat, and then go out to a variety of different outputs. And the outputs that GT has is constantly increasing. You know, we worked with Rich to support Word outputs. We're working with him right now to support like direct plot outputs, and he's actively working on RTF outputs. So this working together, working with other tools that exist in the open source ecosystem, it gives us a multiplying effect. So we don't have to worry about how do I write to RTF, because writing to RTF or writing out to Word can be really complicated and really difficult. But if we're able to offload that and just use the work that somebody else did, give them credit, of course, but use the work that somebody else did, then we don't have to spend so much time working on that. And so through this, we're able to go from end to end, go from our SDTM to our table outputs, wholly using R in a very reproducible way that we can, from the very beginning, regenerate our atoms, regenerate our ARDs, regenerate our outputs, and confidently know that everything's going to be correct. So we spent a lot of time talking about all these various tools. I mean, you've now, like I said, been here for nearly 7 hours, but these tools are intended to save effort. There's a lot of value in working with these open source tools. There's, like we said, there's a little bit of upfront effort involved in transitioning over and setting things up, and there's of course a learning curve. I don't want to minimize that. There is definitely a large learning curve for this, but I think that the benefits outweigh that quote risk, and will improve over time, and we're able to come up with things that make our lives easier. Next, we achieve more by working together. So traditionally, it feels like I've been working in the pharma industry for 8-ish years or so, and it seems like there's a lot, or traditionally there's been a lot of very closed source, very separately working, people working separately to solve the same problems. How many companies have people worked at now where they have to relearn how you're supposed to create tables, relearn how you're supposed to be creating your atom data sets, because every company has a different set of code that they use, and it's incredibly, every time you go to a new company you have to relearn. It's like you're a fresh programmer again. Yeah, you have your knowledge of the programming language, but how exactly the company that you joined, how they work, is a little bit more difficult. Next, we're able to, I think we talked about this a little bit yesterday, how open source allows us to share code, but then not only that, but identify potential issues with the code and improve it over time. By working together, we're able to increase the number of users and therefore increase the likelihood that we uncover potential bugs and address them. We want to make sure that the code that we produce, or the data that we produce, is as reliable as possible, and that means our code needs to be as reliable as possible. And we achieve more by sharing with each other open source code and catching each other and trying to fix it as we go, and generally trying to improve it. So next, how can you help? What are the ways that you can actually help us? And we've talked about this a fair amount. I think we talked about this at the very beginning today. We've got GitHub pages there are GitHub pages, GitHub repos for all the projects that we talked about today. And so as you start to adopt and start to use these tools, giving us the information of how it went when you used it, what was confusing for you while you were using that tool, that maybe the documentation didn't clearly cover something that you're trying to achieve, and therefore you're not sure how to do it. Telling the developers that you got lost is important to them. That way they can improve the documentation. Or maybe, as Christina, I think, mentioned earlier, you're asking for a thing that it doesn't support yet, but they didn't think of it. I mean, we saw that today with the Unicode characters. We didn't think to check whether Unicode characters were able to be inserted into our formats, but clearly they work. And that's actually really cool that somebody was able to come up with a suggestion like, hey, did you try this? And we were then able to throw it in and actually try it and see how it worked. And it turns out we were able to support Unicode. We didn't even think about that. And so just using these tools and giving feedback to the developers is really important. Next, additional ways you can contribute is, we've talked about the Pharmaverse, which is supposed to be an opinionated collection of packages that are to help people do end-to-end clinical reporting in R. So go to that website, see all the different tools that exist, and give feedback on all those. Try to pull them into your organization and see how they can be used. I think it's just kind of, there's this, I think our studio likes to talk about this virtuous cycle. And I'm going to use it in a different context than what they talk about, where I'm saying by using this and giving feedback to us, we're able to improve these tools, which is able to make your life easier, which is then able to increase the use of R and increasingly make your life easier. And so by working together, it's going to improve the interoperability. We're able to have these skills that are transferable and work together on these. And then, of course, report bugs. However many times we've said it in the last 2 days, report the bugs that you come across, report the issues that you see. Otherwise, they may not know they even exist. For that, I mean, this is donation. So donation of your time too is also appreciated. So if you feel comfortable enough to support these projects as well, I'm sure most people will appreciate not just submitting bug or issues to them, but also, if they feel comfortable enough, providing solutions to these bugs, providing ways that they think or that they can improve the code, and being open to working with these folks that are donating their time already to these open source tools. If you're able to donate any time too, that is fantastic. So I'm going to close with, why have we spent the last several days talking about R and open source? And really, I think it's coming, it's happening. There's a tidal wave of people that know R, that are in the pharma industry. There's so many tools now that exist. It's just a matter of time until it just becomes commonplace. And last month, or no, not last month, a few months ago, our consortium held a panel where they had folks from the FDA show up, and they kind of talked through their use of open source, which is really exciting to see and hear directly from the FDA, or folks from the FDA. They're representing their own opinions, to be clear. Like little note down there that it's their own opinions, but talking about how they use open source and how they like it. And I think it overall is going to improve the quality of the code by using open source and by sharing openly. So finally, thank you all for spending so much time with us the last 2 days. We really, really, really appreciate it. I think we've learned a little bit about the folks that are attending are in pharma, and learned what things matter to you. And so now we can take this back and try to improve TFormat, Admiral, and all these other packages to make your lives easier. And I think Christina might be closing out with the Slido quiz.
Actually, before we do that, there's a couple of things that are happening. First, Thomas, go.
Yes, if I can just quickly share my screen. I would like to tease an upcoming event.
Go for it.
Yep. Can you see the slide?
Yeah.
Yes.
Nice. Okay, so we have planned a hackathon on Admiral, so one of the tools we've been using yesterday, and that is sponsored by the CDISC Open Source Alliance and will happen next year in February. And basically, you will have the whole of February time to, given some SCTM data we'll provide you and some specs, and then using Admiral as well as tools like MetaCore and MetaTools we covered yesterday to kind of create the ADAM datasets for this fictitious study we'll provide to you. And for all of you out there who are not yet quite that familiar with R, we'll have a pre-hackathon R workshop. So this is really like an intro to R for SAS programmers kind of thing. So that is planned on the 17th of January. And then we'll have the actual kickoff event where we go into the logistics of the hackathon, but also do a bit more work on Admiral. So that might be a good refresher for those of you who've been here yesterday as well. There will be more info coming out soon, but I just wanted to let you know this. So bookmark that in your calendar and yeah, keep an eye out. There will be more communication going forward.
Okay, so now I'm gonna just take over again very quickly. I wanted to show one thing, and then we have the Slido quiz to just close out. The one thing I wanted to show is people were asking about alignment and width of column things, and both of those things are possible with TFormat. We just didn't have an example before. So this is using the example from the exercise that you guys did. So if I'm going to just remove this actually really quickly. So just to show you what it looks like before we add these. So if you have it without anything, it looks kind of like this, which is like pretty good, but oftentimes we want to align kind of on the spaces here. And also this is kind of an awkwardly wide space. So let's fix that. So we can fix that using the call style plan. Call style plan allows you to, stylize the columns. And each one has its own little element column in it, kind of like the call structures. And you specify the column that you want to apply things to, and then either a width or an alignment. In this case, I wanted to say that this first column should only be 20 characters wide, and I wanted to be aligned on the space for all of our kind of data-based columns. And when you do that, you get something that looks like this. So this is much better. You can see it's much tighter. It's put things on multiple lines, and when it's put things on multiple lines, it's still kept that indentation that we had before. And also you can see now all of this is like aligned on the spacing, which makes it much nicer to look at. Okay. That being said, time for more questions. Three people have already gone in and answered the questions of. So, are Pharmaverse packages the only ones you can use for clinical reporting? Give people a second. I guess I can hide the results. Can I hide the results? Oh, I can hide the results. Perfect.
Ooh, that would have been nice. Wish we'd seen that earlier.
I know. I saw the buttons that kept floating up, and I was like, I didn't want to shout at you, Ellis. We're not Slido experts. But the answer is nope. Good job, everyone. Okay, next one. Where in the process do ARDs live? This is kind of a free word association thing. Show results. So I can show, it doesn't train. Does it live at the beginning, in the middle? Perfect. After atoms. Delightful. Middle. Yep. So it's just a middle ground. It's another waypoint. So it helps. It's just another place. Another advantage of ARDs that kind of I forgot to plug is basically you don't have to be QCing formatting. So I don't know how much time anyone has spent QCing that like fact that the person who is doing, I don't know, their actual base put a space before something or did a double space rather than a single space. No one wants to be doing that. That's a waste of time. You know, the numbers are right, and that's all that matters. And so it's nice to not have to do any of that. Okay, next ones. What are some advantages of ARDs?
We only lightly touched on that just now.
Sorry, I forgot. I don't actually remember. Multi-purpose, perfect. Yeah, I feel like I may have swayed the results a little bit, but yeah, they're reusable. It's easier. It can save time. You can do things without formatting and format stuff later. Okay, continuing on. How do you define formatting for a table cell in TFormat? Do you use F-string, format, round, mean? See some answers. Giving it a second. Thomas, are you playing along? Do you know the answer to this?
I have a feeling, but let's see what we got.
I won't put you on the spot. The correct answer is format. Yes. So in TFormat, you use the format functions. So
And just for the record, I
FRN.
have been following along all the time. So
Okay. How do you select which column of your ARD will become the columns of your table? Is it the param, column, label, or group input value? So from, how do you specify? 16 people. I'm going to wait till we get to like 20-ish. Oh, well, there we go. We're now at 20-ish. Ask and I shall receive. Columns, yes. Using the column input will help let you specify which column of your ARD goes to the columns of your table. All right, next one. What file types can you create with TFormat to be, what types? Sorry, it's late. I'm in the UK. My brain is done. What file types can a table created with TFormat be saved to? RTF, Word, PNG, PDF, HTML, PowerPoint. Yes, lots of answers. All of these answers are correct. Everything but XPT. Not XPT, not PowerPoint. Those things.
Those are the trick ones.
But everything else, correct. HTML is the default. It gives you the most options if you want to make it look really, really pretty. But for the most part, we just need RTF and that works just fine. Okay, what was the most important thing you learned today?
This is your opinion.
This is your opinion. There's no wrong answers here.
We love
Tables.
to hear.
Love. Aw,
I like that.
orange
Orange
fun.
Love that.
That's my favorite. Wonderful. I'm glad that you guys had at least a seemingly good time. Oh, thanks. I didn't plan for the Slido to just be like, say nice things to me, but I mean, it's nice. It's an advantage. Oh, that's cute. That's great. Love this one.
Love it.
This is an important question. Did you guys have fun on day 2? Yes, of course, and would have had more fun watching paint dry.
Our egos will only be impacted by this one. If you stayed this late, and you've been here for 75%, you'll still get your credly, whether you thought it was boring.
Yeah. It's okay. We won't be too offended. And I think that's it for today. Thank you guys so much. The slides are available now on GitHub. The content is also available on GitHub. The recording will be available in a couple of months if you want to look at it. It will be on the RN Pharma YouTube channel, so just subscribe, ring that bell or whatever they say on the YouTubes, and you too will be notified when that is available for you. But I want to thank everyone for coming and joining us today and asking great questions and being a great audience. I know sometimes it's hard to do workshops when they're digital and it's hard to hear and see and interact, but you guys have been really great. So thank you so much. And if you have any questions, I think I'm going to stick around until the top of the hour, maybe, or maybe I will. If no one has anything to say to me, then I probably won't. But just raise your hand and we will unmute you and you can chat. I think there is a question hand up, if I'm correct, Ellis. Do you want to do that?
I don't see the hand up yet, but I saw a question going, that's just a great presentation. So thank you all. I mean, this is why we're here, right? Is to help you and help with your adoption. So we're excited that y'all learned stuff, seem to have learned stuff. Didn't leave. Most of you said we were more exciting than drying paint, so that's always a good thing too. We know it can be a not super thrilling topic.
Oh, don't say that. It's a great topic. Come on.
It's interesting, but it's not like they picked us.
Yeah,
I love it.
It's no like I saw some people posting on Twitter about the observable or the observable workshop, which I feel like would maybe have been slightly more fun. I don't know.
No,
maybe
this was the most fun.
Had a great
I think
time.
it was a safe choice to come to this workshop. So
yeah.
So I see there was a question about somebody that said that they registered with their personal email but used the work email for Zoom. Email info if you have any questions about how any of this will work, email info@rnpharma.com. They'll answer it because they're the ones that are tracking the Credly stuff. And if they have anything that like they need us for, they'll forward it on to us and we'll get you an answer as soon as we can. So unfortunately, it's just kind of stuff that we don't know.
We are not responsible for calculating the Credly information, so we can't tell you how to do it. if whatever good enough is good enough, so that is not information we hold.
If I see that a number of y'all are hanging on, if you want to ask us anything, you raise your hand. We can talk to you in person. Yeah.
And I guess at this point,
add us on
fairly
LinkedIn,
generic
sure.
questions as well.
Yeah, you can ask us other questions. You can ask us all sorts of things. How we got started with I don't know, who we are, what we do.
Kind of skipped over that.
We did it on the first day.
A little bit. I like this comment. Van Gogh used paint. Touche.
There's a nice comment in the Q&A here. One of the most useful trainings I have attended so far. Thanks a lot. So Hans, thank you.
Thank you.
Everyone's really nice to us. That's lovely. I regret saying top of the hour. I'm not sure I can wait here if no one has questions. Although it is lovely to get very nice comments. I probably don't have the dedication to sit here for quite that long. It must be super late for you, Thomas, because you're an hour ahead of me, right?
Like it's almost close to 7, but it's okay. I actually have another meeting after this, so hey.
What? No, no. Just say no. Walk away from the computer, Thomas.
I took a long walk this morning, so I got my fresh air. It's all good.
Somebody commented asking about the white paper we referenced earlier. I'm not sure what you mean by that. Is it the?
Yeah, it's the Novartis white paper. Where are you seeing that? I don't even see that.
I saw it earlier.
What was the question?
Can you link the white paper that you referenced earlier?
The link is in the slides. The link is in the slides.
I think everywhere there are slides, unless you're referring to the white paper on validation, and that's it. What's it? PharmaR.org. Oh, I'm saying that wrong. Just search our validation hub.
Yeah.
So there's a question on slide if people can add us on LinkedIn. I think yes.
Yeah.
Go ahead.
We're here.
You can get all of, I mean, I don't post much on LinkedIn. My posts are mostly when my packages get updates. For those who, I don't think we were super clear on this, I'm the maintainer for Metacore, MetaTools, and TFormat. And yeah, Ellis, you maintain, you maintain many things, but that we didn't talk about today.
None of them are really pharma specific stuff. If folks do Tidy Tuesday, there's Tidy Tuesday R. If you want to record your plots just record your plots as you create them, there's Camcorder. Those two are on CRAN. I've got a package, I haven't touched it in a while, but Val Tools. So if you're working on validation stuff, we have a white paper on Fuse explaining kind of a process of how you could go through and validate your internal packages. Got another question about the credential or the badge or certification. That's through Credly, that's through RN Pharma. If you attended both days of this workshop and attended over 75%, you'll get it. And it's tracked. If you have any questions, email info@rnpharma.com.
There was a question about the RN Pharma YouTube channel, so I just pasted the link in the chat. And then there was another question around the slides for today. So that is on GitHub.
Put the answer to them, but also, yeah, it's this one GitHub that we've been sending around. I regret naming it that way because it turns out the like CI/CD people also put their thing in, but they put theirs in after us. So, you know, we were the first in, so we got the better name.
We can always rename it and it'll auto redirect, but
too late.
We committed.
We committed hard. Yeah. Don't think I have any other questions.
Let's see. I'm still seeing 4060 y'all here.
Just hanging out with us.
You're just hearing us blather.
Yeah. I mean,
are you guys coming to Fuse in like next week or the week after?
No. I didn't. Fuse requires you to be really on the ball and like be there very, very, very early. Eric, I'm giving you the ability to unmute yourself.
Hello, thank you guys for the presentation. This is Eric from Kenya, Nairobi, Kenya, East Africa.
Awesome.
So how do you guys learn? Did you switch from SAS to R, or did you switch, or like what was your first language in terms of clinical programming? Did you guys start with SAS, then you came back to R, or did you guys learn both languages at the same time?
I'm happy to start. I will fully admit I've not really been a clinical programmer. I was a clinical statistician, but I've never been a clinical programmer. I just play one on TV. That's what I always say. In that, like, I've helped and been a part of that for a long time, but I've not done a lot of this work. But I started with a language called Scheme that no one has heard of. And yeah, so my first language was Scheme, but I eventually wandered into this, and I like in my degree program I have a master's in biostatistics. I learned both SAS and R kind of simultaneously. But because I have a background in more like computer science and object-oriented languages, I have a preference for R, and I always have. But that's mostly just my special weird path. I don't know. Thomas?
Yeah, I started off with R around 8 or 9 years ago. So now, so I was working at the university and we had a PhD student I was helping when I was still in my bachelor's, and he threw an R script at me and was like, yeah, just run that. The output is what you need. And of course, that didn't work. So I kind of digged into learning R. And then when I decided I want to join Pharma, I actually learned there's this thing called SAS, which I never heard of before. That was like 4 years ago now, probably. And so I did like the Coursera specialization on SAS, which was good. And then I did like these certificates. So for what it's worth, I'm an advanced SAS programmer, but don't ask me to write like a SAS macro also at this point, because at Roche, R is like in high demand. So let's just say I don't get an opportunity to write SAS code, or at least people put me on other stuff. But yeah, that's my journey. So Ellis.
Yeah, so my degree is in bioengineering. So the first programming language I had was in MATLAB. That was the language that they taught us at school. And so that was kind of what I did for a few years in school, working with my professors and whatnot. And then after I graduated, I went and got a job at a CRO, and we were doing statistical genetics, which is not really SAS world. And so I was supporting a bunch of statisticians, and we were using R and specifically bioconductor, which is like a subset of R, like packages from R. And so that's kind of where I cut my teeth, was learning how to support a bunch of people that are doing some crazy stats and crazy large data. And so that was what I spent several years doing. And then that's where I learned R. And then it was also like our IT guy too. So, but of course, you don't stick with one language, right? Like once you know how to program in a language, at least generally, this is my opinion. Once you know how to program, it's easier to pick up other languages. In the sense of like, you kind of understand how a computer thinks, and it's only going to do what you tell it to do. So if it's doing something wrong, it's because you weren't clear enough about what you wanted it to be doing. So then it's figuring out the syntax you need in order to tell it what to do. So then, you can go and learn, once you know R, you can go like Python or the other way around. Python's definitely a great language too. JavaScript, Java, all those other languages, but having a good baseline is kind of important.
Okay, thank you.
For sure. I don't know, and I found that I tend to just fall back on R now. Okay, I know all these other languages, but R is it's my comfort zone.
R is my comfort zone. For like, apropos of absolutely nothing, but I guess like the 40 people who are left here are really the real dedicates of this. Every year there is a thing called the Advent of Code. It's not related to Pharma in any way, but it is like a kind of fun coding challenge. It's like an advent calendar type of thing. So it's it starts in December, the beginning of December, and they give you a new thing every day. It gets progressively harder. I usually make it as far as like day 15 or so, and then I give up. But if you want to like polish up your coding skills, because you just want to do some coding in a fun, low stress way, that is I don't know. I like doing the Advent of Code. I tend to do it every year, but yeah, teach their own.
I mean,
Okay.
we managed to stretch it out another 20 minutes. So
I did. It turns out we're good at talking about nothing for periods of time.
So I think we can probably end this unless somebody else has a rapidly burning question. But otherwise, I am not seeing any new questions in Slido. Nobody's raising their hands.
No,
So
I feel like a question at this point would be very far from rapidly burning. It'd be lukewarm at best.
maybe.
Tepid. You have a tepid question.
All right, so let's just end it. And
Yeah.
thank you all for almost lasting 8 hours with us. I'm proud of y'all.
Good job, everyone. Thank you.
Take care, y'all.
Bye.
Thanks, everyone. Bye.